So I guess with that, we'll go ahead and introduce you to these concepts. Obviously, what it really is directed toward, of course, is people. People is, of course, the motive for who and why we are involved with this. The constant, of course, in this equation is the environment, right? And the environment plays a significant role in workplace health and wellness and safety, because environment is kind of like the word stress. It's multifactorial, right? There are many, many stressors within the workplace environment. And so that's kind of like the constant. And so obviously the words methods and machines, mechanics, there's a great deal of, shall we say, interactive dialogue in this, shall we say, dance of the workplace. We call it, therefore, the human workplace interface. And as we think about it for a moment, after you share this, what I believe to be one of my favorite all-time quotes, Jean Giroux was a radiologist, and one of his long ago publications made this observation. And I think it's something you can take to heart, and I think this whole profession could take to heart, right? That the highest level of chiropractic service is to engage in what we can do to prevent the problems that we treat. And of course, you'd say, well, but nobody pays for that because we have to be practical, right? We've kind of inherited this medical model, which is kind of driven by the crisis consciousness, and we wait till there is injury or illness, and then we heroically intervene, and we call that healthcare. And of course, we realize and recognize that something is missing in that equation. So I really hold this as being one of my all-time sources of inspiration. So why? Obviously, we would want to suggest that we should follow this admonition, urging every clinician, regardless of their discipline, to consider, the idea of proactive prevention approaches to injuries, human suffering, and disease. This ultimately is the reason for Northwestern's existence, right? In terms of its broader picture, why are you here on the earth, that is, and of course, how can you best serve, what you're calling to become a healer? So looking at some language now, and much of our training this weekend, doctors, will focus on semantics and vernacular and kind of acquainting you with, if you will, the culture of the corporate world, and then just becoming familiar with terminology that you may not have necessarily been exposed to in the past. So just defining the term comes from the Greek, looking work and nomikos, and therefore the studies of the laws of work. And that was originally coined by this gentleman in 1857. So this consciousness has been around for a long time, but even earlier than that, and we'll get to that in a moment. In the old days, in fact, when I was first introduced to it, it was still referred to, this was the days before the 70s even, before the feminist movement, which I constantly hold in extraordinarily high regard because of all of the inequities that existed and continue to exist in terms of human equality. But the point was, it was at one point referred to as the man-machine interface. But more than for political reasons now, we don't use that terminology. And by the way, make a mental note of this. Make a written note of it. It's not workman's comp, may I remind you. It's not workman's comp. And yet you'll hear that all the time. You'll hear doctors say it particularly, but it's still, kind of like the old mindset. Realize that most of the time, your first interaction with the corporate world is going to be with who? An HR person. Statistically, do you think there are more men or more women? So you want to be sensitive about the language that you use. So you say workers. And by the way, in its, shall we say, grammatically correct rendering, the apostrophe follows the S. See, a worker is an individual worker's compensation, but when you're talking about the broad picture, so it's workers apostrophe, okay, with the apostrophe following the S. again, it's sensitive, it's subtle, but you see, you're making an impression. And so the impression will never be observed unless it's wrong. That's when it'll be observed, right? And as we say, you're dealing with very much a people business, as we know. And in terms of your success in this, of course, is how well you will be received in that regard. So this is what we say in terms of being sensitive, to our interaction working with it. Another term used primarily within the professional or ergonomics community is what is referred to as human factors engineering. It's simply a synonym of ergonomics. That's just another term that's used, and obviously there are human factors engineering societies and organizations and so on. So just realize that if you go on the internet, for example, and start checking on ergonomics, you'll come to this quite often, actually. So this is why we want to mention for a moment, folks, that as you know, the world is rapidly moving toward what we call the integrated model. And that is to recognize, of course, that no one discipline or one individual has, shall we say, the total answer. And so there will be many times when, in fact, the demand or the challenge that you'll be facing might be outside of your level of expertise. But that shouldn't trouble you very much, because you will be an expert in a number of ways that others will not be. And so we just realize that there will be times when you'll need to think in terms of going outside of your level. So let's look at that for a moment. Since 1990, which is really pretty, shall we say, a recent evolvement in the world of academics, this credential, and therefore the highest credential in the science of ergonomics, is referred then to as a certified professional ergonomist, and the acronym is a CPE. Some of you in the diplomate program, again, you might remember David Gilkey, for example. Dr. Gilkey teaches at Colorado State University. He is a DC CPE. So he's got a whole bunch of other designations besides. He's a perpetual student, but he's a great scientist and a great friend, and also he serves as a mentor and the facilitator of the doctor's projects in the diplomate level program. So when you're doing your required field project, which is what Don was describing, Dr. Gilkey serves as the individual doctor mentor to make, shall we say, making sure that it fulfills the requirement. It's kind of like a process of fulfilling all of the components of the program. And so in any case, that would be an example of one of our people who is both a chiropractor. He's also board certified in orthopedics, board certified in occupational health. He's also got a lot of credentials toward the industrial hygiene, which is another discipline related, which we'll talk about a little bit later. Minimally, usually master's degree or PhD, sometimes also referred to as a board certified professional ergonomist, and then you might see that designation. Now notice this, you guys, currently only about 800 of these people. For how many business do you think? In this country, it does fluctuate, but it's between 6 and 800 million, no, excuse me, between 6 and 8 million businesses. And of course, every day a business is born, or maybe dozens of them. And of course, you also know that many businesses don't succeed. So that's not it's like a moving target, but keep in mind, folks, if the world depends on, right, the business community, really there's a relatively small number of professionals, and of course many of them are academics. Many of them are involved in shall we say, laboratory research. They're not working in the field. So you got to put that in perspective, that they're not necessarily available to the corporate world as you might expect. So there's a great potential for people who have an understanding of the core concepts of ergonomics, which is what we want to share this weekend. And then, of course, there's a lot of other folks involved now. Occupational physical therapists have been involved for quite some time, actually. And in fact, part of their core training at least in many of their schools. Industrial psychologists, medical doctors, and more recently doctors of chiropractic are becoming involved in this field. And then we'd like to touch for a little bit regarding the history and from whence it all began, so to speak. There's records actually that go back into ancient times as it relates to understanding the relationship between work and human struggle, human suffering, so to speak. And this is the individual that, because he is the earliest published, shall we say, observer, scientist in the sense of making the consciousness come alive to his fellow healers at the time. The most highly regarded expression of this interest in the medical literature were the words of this gentleman, Bernardino Ramazzini, in his 1713 supplement to his publication, Translated Diseases of Workers. And this is his now very famous quote: "Various and manifold is the harvest of diseases reaped by certain workers from the crafts and trades they pursue. All the profit they get is fatal injury to their health, mostly from two causes. The first and most potent is a harmful character of the materials they handle." If you think about that for a moment, think of 1713, and then think of the harmful materials that workers might have been handling. So you think of, say, garment manufacturing and perhaps working with chemicals that were involved with dyeing of cloth. Think of leather and tanning, think of the acids involved. Think of metallurgy, right? The early production of tools and all kinds of things, and all of the chemical potential hazards. That's what he's talking about. And he says most potent. What does he mean by that? Well, most likely to kill you, right? I mean, it could be fatal. I mean, that's the reality. Not necessarily the most common, which we'll touch on. And then he says, the second cause I ascribe to certain violent and irregular motions and unnatural postures of the body, by reason of which the natural structure of the vital machine is so impaired that serious diseases develop therefrom. Again, note the date. And then we ask you to think about that for a moment. Think about the fact that how this gentleman, ultimately earned this title was based on that observation. Let's look at this quote, though, for a little bit longer, and then reflect on it with me for a moment. It says that when the natural structure of the vital machine is so impaired that what happens? A crick in the neck? A kink in the back? Or what? Serious diseases result from what? When the structure of the vital machine goes haywire. Does that sound like D.D. Palmer? Does this seem to fit with chiropractic theory, folks? And that's the beauty of it. I don't know of a closer sister science than the application of ergonomics as we come to understand it. Now, this event in history probably was the most significant game changer as it relates to our health care, or if you will, the people that were involved in terms of dealing with ergonomic issues. It stemmed from the events surrounding World War II and bringing modern warfare into an environment that, shall we say, made it relevant. And I think one of the evolvements in terms of the war in the Pacific, most specifically, what technology allowed, if you will, the Allies to engage, if you will, the Japanese, that didn't exist in World War I. It was the aircraft carrier, which meant that here was this football field, maybe 3 of them, where an aircraft could land and take off, right? Now, if you think of the aircraft that were designed to land on a moving ship out in the middle of the ocean, then you had to think in terms of, do you think these were 6'8", 280-pound people that were drafted to fly those aircraft? And do you think those aircraft were made out of steel, or do you think they made them of aluminum and so on? Do you get the idea of the engineering challenge of creating aircrafts that could effectively do that. Now think of the cockpit, right? Think of the cockpit. And so in the early times of an aircraft carrier, they were training these pilots. In a training environment, they were very, very successful. They grew to a level of, let's say, comfort zone such that they had very little problems until they were under fire. And if your wing is on fire and you're trying to land that aircraft on a bouncing ship, now here's the interesting thing. What they learned is that all of the, I don't know, do any of you fly private aircraft? One of you, well, the bottom line to it is that your controls, of course, is going to determine whether you live or die when you land and take off, right? Bottom line to it is that what they did then, they found that all of the control levers had the same shape. So what they decided, because these aircraft, again, under battle conditions, they were coming in and literally crashing into the aircraft, or they were overshooting and landing in the ocean and exploding. The bottom thing is that they were, at that stage under extraordinary emotional stress, right? And therefore, their consciousness was in a different zone than when they were in a training mode. So what they did to change that, they shaped the landing gear, the wheels coming down, like a tire. Literally, you grabbed the control and it was shaped like tires. And then the flaps on an aircraft, they shaped the handle. They created it such that you had a feedback link so that the control, then your consciousness was facilitated, if you will, by the tactile response to the shape of the control measure. That would be an example of an ergonomic intervention that made all the difference in the world and dramatically changed the outcome. So let's put that in perspective and then realize, of course, there's many, many other considerations. How about a tank? I mean, tank warfare, having 6 soldiers inside of a tank and then having them operate efficiently, right? Or and any of these things. So this gives you an idea why and when this really changed the perspective as to the importance of design. It's really all about design and then making that human interface a user-friendly one, right? For all of the right reasons, you can well understand that. So aircraft, ships, aircraft carriers, submarines, increasingly sophisticated engineering and complex, human errors in their operation became common. Therefore, catastrophes and a lot of non-combat casualties was the result, which of course stimulated this. So in response, engineers, psychologists collaborated. Why would that be the case? Well, we're talking again about human behavior, human response times, human perceptions of things. That's where psychologists come in, combining that logic with engineers and the design people. So, of course, right away that tells us that this is a multidisciplinary approach to anything having to do with sophisticated ergonomics is always going to include. And as you observe here, this team of people, anthropologists, industrial engineers, cognitive scientists, physiologists working to understand the human operator in order to design systems and machines that were more appropriately fitting to the user. Today, ergonomists can be found in military, aviation, aerospace, and energy, medicine, transportation, as well as in virtually all major corporations around the world. But as we said, there's only 800, right, give or take, that have the credentials to probably respond to the total challenge. So as we mentioned again, looking at that from a purely business perspective, there is this great opportunity. And of course, think of rural, non-urban societies and how many of these PhD ergonomists are likely going to be able to, shall we say, find their life calling and working in communities where you folks practice, right? So now, what is ergonomics essentially based on? For many of you, this will be a new word, the word anthropometrics, right? Think of the word anthropology, study of human beings. I think you all recognize the notion then of the word metrics, is that it's simply the idea of why and where the human machine fits into and becomes an extension of a manufactured machine, so to speak. So anthropometry can be defined as a measurement and study of the physical features physical features of the human body. And so this is, again, the research component of ergonomics in terms of the people who actually design this stuff. It's based on these measurements. And in simple terms, so to speak, it's all about body parts, right? For example, based upon anthropometric data, assuming he or she is not notably overweight, the human head weighs approximately 7% of a person's total body mass. So if you look around the room, I think all of you, I don't see an obese person in the room. Therefore, you can calculate the weight of your own head if you looked at your body weight. 200-pound person's head, therefore, weighs approximately 14 pounds, and a 100-pound person about 7 pounds. And so we have to think about that, particularly now, like if you're looking at, say, the ergonomics of the seated worker, which we will be spending the last portion of our time tomorrow on. Following this logic, a person's arms, and that is together, both not each, also weighs about 7% of his or her total body mass, equal to the weight of the head. Consider this then positioning a worker in front of a computer screen for 30 to 60 hours a week. And I think all of you know, obviously the concept of reach and then where the head is in space in terms of where it is balanced. You're not conscious of the weight of your own head as long as it's positioned over your body mass, right? But after, of course, of course, yeah, it's like the fester, right? It's continuous, a stone in your shoe, so to speak. Terribly distracting. And of course, you guys know the word presenteeism. That refers to the person who's at work, but they're really not at work because they can't concentrate on their work. And to that end, that's a huge problem in the corporate world because people will come limping into work, but of course they're not as productive. There's a lot of factors that we could talk about in that regard, but this is how and why we do anthropometric measurements and putting it into the equation of what needs to be done. And then we have to look at the idea that it's not just simply the static mode, but obviously the dynamic consideration as well. So dynamics, of course, include such things as reach, range of motion, clearance distances, not only, shall we say, between your machinery that you're working on, but also between people, and also the entire work environment. How closely can people work together without interfering, and so on. So. And that's why these total considerations come into the picture. In addition to anthropometric differences among genders, designers and ergonomic consultants need to be cognizant of demographics. And as you know, there's a huge change in American demographics in the last 40 years. I think you'll know, for example, it won't be long until the population of California, the Caucasian population, will be the minority. And that's not far off. And of course, there are unique differences, right? I think we know classically the Caucasian body mass in large measure is usually larger in bulk, in both vertical height as well as in each of our body parts, say from two common population groups in our culture today, and that is the Hispanic population and the Asian population. Usually, these individuals statistically, demographically, will be smaller. And then think in terms of the traditional American workplace that was designed clearly for mostly Caucasians, right? And so in terms of an ideal fit, that's the challenge. So we have to put that into the equation. Very, very important consideration. And then, of course, the obvious between male and female. See, in recent years, there is, I think by now, does anyone know the current data on the ratio of male and female full-time workers in America? When I was teaching this back, when we did the diplomate program, it was 48-52, 48% female workers, 52% male, but they were projecting that it would even out. By now, that's probably taken place. So put that in perspective as well. The average female is, say, 10 inches shorter, let's say on average. We don't know. I don't have that data in front of me. By the way, a lot of the early ergonomic data was based on military And almost all of it was based on males again. So that's another example of the inequities in terms of, how science has sort of lagged. But now it's changed dramatically, fortunately. So, and then you'll be hearing about this. This is another sort of semantical thing that I want to kind of share with you, and yet don't have to get too concerned about it, but you'll be hearing about the 95th percentile. And of course, the design of the entire work environment has to be sensitive to meet this challenge. And that is, of course, that it's going to, whatever your design, in order to create the best possible environment, an employer has to think in terms of meeting this standard of the 95th percentile. So what does that mean? That we can't design for the average. For example, average, if you think of median and mean, you have to be thinking in terms of, if a doorway was designed for the average height of individuals, obviously half of them would bump their heads, right? So we have to design for the shortest individual as well as the tallest individual in a working population, so to speak. That's used as a kind of a simple expression of it. But what is the definition of this? In a mixed total population of 50% men, 50% women, the fifth of the 95th percentile ranges covers 95% of the workers in that environment. Okay, the top 5% of men and the bottom 5% of women are excluded, but because only half of the sample are men, half are women, this equals 2.5 times 2.5 equals 5. So the total, that's why it gets a little bit confusing, but just realize that this is what is expected in terms of meeting the challenge. And I should mention this too for a moment, you guys. How many of you remember during the Clinton administration, there was a movement afoot to create a national standard, a national ergonomic standard? I know we probably talked about it in the diplomate program, but that was going to become government law. It would have been federal law that would have mandated employers to meet this standard. Not necessarily an easy one, right? I mean, that would mean a lot of retrofitting and a lot of, kind of like the ADA law. Remember what that was about? Remember the going back, right, in terms of, the changes from the OSHA law, which started in, Don, what year? 1970, Nixon administration, right? Then, though, 1990, the ADA law, right? Americans with Disabilities Act, people who had physical compromise. So that meant what? You had all kinds of ramps, right? You had to have a wheelchair accessible bathroom. So what do you think? Employers were excited and thrilled and happy about that? To the tune of millions and millions of dollars of expenditure, right? So kicking and screaming, right? Obviously, it's not an easy challenge to make those kinds of societal changes. And yet, for humane reasons and to facilitate the ability for physically challenged people to access a workplace, which they're most deserving of, just because you're in a wheelchair doesn't mean your brain atrophied, right? Just because you've got certain physical, that's the point of it all. And so to that end then, in the 1980s, in the Clinton administration, there was a movement afoot to create this national ergonomics challenge. But of course, as soon as the administration changed and went GOP, then of course what that meant is get government out of, the marketplace. And so ultimately it was defeated, except for one place. Anyone know? Actually, no, California does have a standard. And they, I don't know if it was as stringent as was originally planned during that early time, but just kind of put that in perspective. It does have the most stringent of ergonomic standards for any state. And I think that's kind of what the Fed said. We're not opposed to this. They're just saying we leave it to the local, sort of, if you will, jurisdictions and let people decide if they feel that's of high enough priority. Go ahead, Don.
In 1970, what occurred?
Oh, it was the OSHA. See, OSHA, is federal. I mean, we could touch on that a little bit more, but so we'll take a moment to do that. In the early age of, or the early time of an OSHA's intent was to, preserve human function. But higher priority was what? Prevent fatalities, right? Loss of life, then loss of limb, right? Loss of life, loss of limb, and then human function. And that had to do with vision and hearing. So those things became commonplace in the workplace. You had to shield, gears and all kinds of pulleys and belts and whatever. Yeah, so in 1980, 1970, after, again, Ramazzini in 1713 said it's killing people, causing all kinds of problems. Maybe we ought to start thinking of, setting a standard to prevent this. And then, of course, not volunteer, it's forced, right? Which now, of course, OSHA has, it's no longer the issue that it once was for employers. I mean, everyone is compliant, simply because if not, they think about a $50,000 fine, shall we say, for the first violation. So just kind of think of it that way. Compliance now has become an issue. So that's kind of the sequence of things, folks, in terms of then in the 80s, it was said that life, limb, of course, right? Life and limb, hearing and vision. But then it came to the realization that, where are the greatest costs? Time loss, neuromusculoskeletal disorders, right? And the Fed uses MSDs, musculoskeletal disorders. Chad knows my pet peeve. When I hear chiropractors say musculoskeletal disorders, I say, are you a chiropractor? Have you heard of the nervous system? Where do you think pain comes from? Doesn't come from muscles, doesn't come from bones. Get it? That's my point, you guys. It's a neuromusculoskeletal disorder, right? I think you all realize that. It's not to emphasize it too much, but only to say that that's an issue. And the goal, of course, is to be able to fulfill the needs of 95% of the workers. Because if you try to, cover everyone, it really would be too, shall we say, it's usually not cost effective, quite frankly. Then, though, and we'll talk about that, this term, maybe you're familiar with it. If you've had some familiarity with the work comp system, you probably know, at least here in Minnesota and most states, I believe, this concept of reasonable accommodation, where employers by law are obligated to provide, and that's of course this thing called the ADA, again we touched on 1990, when there's an issue where the individual has, shall we say, where they are outside of this 95 percentile category, then there is this need for providing reasonable accommodation. One problem with that, though, is that it's not been clearly defined from a legal perspective. And just kind of think about that as well. There's always room for discourse and always room for the employer to say, whatever make do. But to this end, then, recognize that it could be a source of conflict between the employer and the employee. And so in many, many cases, there would be examples of it. So obviously you can think who would fall under that. Obviously wheelchair-bound individuals, amputees, late-stage pregnancies, severely obese workers, and so on would be examples of people who would need what we call then reasonable accommodation. But because it's not well defined so that you could say it would cover everyone, it's looked upon on a case-by-case basis. They would take it up and then have to address it. Now, when there's a conflict, usually the employer, if they value that employee, right, what are they going to do? They're going to do everything they can to make it as user-friendly and as helpful as possible. And but sometimes when they feel the reasonable accommodation would be expensive or maybe not really as simple as it may seem on the surface, the employer, the law would kick in when it's deemed a medical necessity, and that's where you guys come in, right? As long as the employee and the employer can work it out, no problem, right? But when there's a conflict, then the employer might say, well, you got to get your doctor to verify. Then they're on notice, if you will, to meet the law. They would then fall into this category. And so just that's the language we use. That's what is known then as medical necessity.
So it's probably easier to get an accommodation. If you didn't have one, you're injured on the job, it's probably easier to get an accommodation and try to get a job you never had if you have one.
Well, precisely. That's another thing. If for some reason your inability to perform your original job comes into the equation, well, of course, then there has to be medical documentation of that. How many of you guys are working with QRCs now in the work comp system? Do you know what I'm talking about, a QRC? Sometimes they're referred to as a CRC, a Certified Rehabilitation Consultant. The QRC is a qualified, in Minnesota that's the language they use, Qualified Rehabilitation Consultant. That would be for the worker who is unable to go back to their original job. The QRC is a professional that then the insurance company hires to facilitate that process. And so it's a little bit outside of this discussion, but just again to acquaint you with, that's another professional that's involved in occupational health. And of course, for many people, it's a life changer. It can be profoundly important because if the worker is left on their own, let's say if you're, a bricklayer, block layer, if you're laying cement block and they, you blow a disc and it's determined that you're not able to go back to your original job, well then, let's say you're a high school dropout and you learned your trade as a mason on the job. Maybe your uncle had a construction company and at age 16 you became a mud tender, right? And that's how you learned how to lay block. And now you're 44 years old and you've got 3 kids in school and you're earning $26 an hour or whatever, even though you're a high school dropout, right? So do you have transferable job skills? Well, that's where the QRC comes in, folks, to facilitate that return to the workplace. And again, it's governed by law in Minnesota. In many other jurisdictions, it is as well. Excuse me? Department of Vocational Rehabilitation. It is related to that, although it's, again, in Minnesota, it's unique. I think we are one of the states where there's far more focused attention to it. And I have personal involvement with that because I chair the panel that regulates these folks and also responds to we're a disciplinary body and we also establish the rules that regulate them, but that's what their service and role is. So, and as we touched on a moment ago, human behavior becomes a focus as well. Ergonomics applies biologic or biomedical physical engineering principles to the social sciences and the analysis of humans interacting. As we said before, how people perceive their environments and respond to it is a really critical component of it. So the goal, of course, is to find this proper fit, the optimal fit between the worker and their work environment, regardless of their circumstances in terms of what brings them into the work environment that's unique. And we touched on that before, their age, their gender, their physical capacity, and their anthropometrics and so on. And then as we stated, as we said, to arrive at the most appropriate workstation design that remains sensitive to the majority of the workers regardless of gender, the cost-benefit ratio, right? The return on investment is a critical thing for management. You have to realize that there's a point at which they're going to say, we simply can't make reasonable accommodation. And in some cases, they're legally entitled to do that. And that's another component of the broader training. But you have to realize that cost-benefit ratio is an issue that you're going to have to take up with the employer on a fairly regular basis. That's why we tease this out, you guys. We tease it out as this, the $19.95 rule. Anything that's over 20 bucks, no, we can't do that. It's too expensive. So we jokingly say, well, $19.95. So the economic reason most employers will initially show resistance to recommended workplace design modifications, especially in the retrofit mode. The time to do it, of course, is when they're originally designing it, right? I mean, when they're creating a new wing or like a new process, well, that's when they should call you in to facilitate and help them at that point. Because if you're going to change it after the fact, tear down a brand new facility and start over? Well, that's the issue, folks. And of course, in most cases, we try to stress the idea, if they have any plans for expansion or changing a major process, don't wait till there are problems, right? You got to get on early. So consultants have to always be sensitive to looking for the very least expensive way to successfully accomplish an end objective. As you might expect, doctors, ergonomics deals with a lot of factors. We talked about the environment being the primary element that we all exist in at all times, 24/7. So to that end then, obviously in the workplace, we have to think in terms of machines and tools, as well as all of the physical stimuli, both positive and negative, and the mental and physical demands of a given task. So in human factors then, when we define these concepts, like when we say, what do we mean by a machine, and of course a tool as well, it's a miniature machine in a sense. Human factors nomenclature machine is any type of physical object, device, or form of equipment that is used in the performance of a work activity. So in a sense, a simple hammer is a machine, right? But obviously it would be going toward the idea of expanding from there. So there are some key considerations that we will be addressing. Principal concerns of industrial ergonomics then are overall design of the workplace to accommodate the physical characteristic of humans. This is where the anthropometrics comes in and the demographics. The design and use of tools in the task performance to meet the physical characteristics of humans, and then the analysis and the design of controls and displays of machines or work environments to allow the worker to operate and monitor processes efficiently and with a minimum of error. This is an area that may not be a common request of the chiropractor consultant, so to speak, but I'm going to ask you for a moment to look at that exit sign for a moment. And what color is it? And is that by design? Have you been in newer environments where the exit signs are green? It's called a stereotypical response, right? When you look at a semaphore, when you come to an intersection, what does red say? So when you, is that sort of oxymoronic then, to think that that's the point, you guys, right? This would be an example, right, of what we call a display, right? In terms of facilitating efficiency of what? Exiting from a burning building, if you will, or where there is a major hazard situation where you've got noxious fumes coming in and you got to get people out of there. Stereotypically, though, your brain says red, that means what? So that's kind of the point, you guys. I just want to use that as a simple example. The development of job procedures and the pace. Now that's another notable issue, the procedure and the pace with which, that's going to be economically, notice that, economically efficient, and yet meet the physical and psychological capabilities of humans in the specific complex human-machine workplace and their environment. Sometimes when we talk about ergonomics with students, we will jokingly say, well, what other word does it remind you of? The word ergonomics. Is there another word that's kind of similar? How about economics, right? So in economics, what are we talking about? Well, in the simplest terms, we could say the best bang for the buck, right? That's economics, right? You invest, and what is your return on your investment? That's the whole science of economics, right? So in ergonomics, substitute the word energy, maybe. How much energy is going to be invested, and what return do you get for a certain amount of invested human energy? Or the energy that a machine puts out, right? Do you need a 60 horsepower, or do you need a 160 horsepower? And how much fuel are you going to waste? Do you get the idea? So economics and ergonomics, but of course, to the employer, without question, the bottom line issues, right? The economics are huge motivators to take action or inaction. It's usually an economic decision as much as they may care for their human, the most important component of a successful workplace. Usually their most valued, if you will, asset is not the computers in their buildings and the air conditioning. It isn't that. Even they're now on cloud and ultimately all the most sophisticated things. It's still the worker, right? It is, without question, all of those other things would be unnecessary unless they were efficient workers to make it all happen. So that's kind of the balance of the equation in your marketing if you're helping employers to understand how critical it is that they value their employees. And Well, again, it became an important part of our earlier discussions in our occupational health training. It's been learned, for example, that more than 50% of the outcome of a successful intervention is worker morale, labor management relations. And it's absolutely a critical component, folks, because you can have, all of the most advanced ergonomic setup, if you will. You can have the most sophisticated equipment. You can have all of the other factors that you would expect to, result in an optimal outcome in terms of human productivity and all of that. But if workers and management are in discord, it's not going to work, folks. So you want to really put that high in terms of priority during your dialogue, in your discussion and discourse with the employer, helping them to understand how critical that is. And there's techniques that we teach and we talk about in terms of you got to interview your workers. You got to do surveys of your workers. Let them do it anonymously, but you got to get feedback from those workers. You have to have an interactive dialogue between management and labor. And oftentimes, especially during down economic times, workers are reluctant. As you know, they're even reluctant to report their symptoms, which means what? They prolong their symptoms to the point where they can't get out of bed in the morning. And then they finally report their work-related injury claim. But now that they've delayed it, they may get it denied, right? They may get a denial from the insurance company because you say it happened, didn't it happen 2 days ago? Or no, it happened 8 weeks ago. Well, okay, we'll talk about that a little bit too in terms of you have to be really, helping the employer to see this critical component, one of which, again, as we talked about, is the pace of the work, is a really important element in terms of workplace morale. And then note the headline, stressors are multifactorial. As we stated earlier, this idea of looking for external stress factors that can negatively affect the efficiency of the human workplace. That's a really underappreciated consideration in a lot of environments, which I think will become immediately obvious. So the first concerns as this class and you folks and your role, you'll come to realize early on that these are not just the issues that you will be facing. Every employer in this country has these same priorities. And then see yourself as a chiropractor to say, well, is this a good fit for me? Should I be involved with this? Because absolutely, in this order, essentially, posture, force, and repetition. And then, those be the top three, and then when there is adding environments where there is, say, vibration, and then extremes of temperature, particularly cold, as it relates to its physiological response. And I think probably many of you know that cold acts as a vasoconstrictor, but so does vibration. So when you have the combination of vibration and cold, you add. Then does somebody want to offer, again, Carmen and Don, don't give them the clue, right? What's the other one, folks? A common one? Less common than it was 20 years ago, though. The addition of what? A lifestyle factor, and what would that be? When you have a worker who's running a chainsaw or a jackhammer, who's in the cold environment, but what else? If they're a smoker, because nicotine is a vasoconstrictor, right? So now you got a multi-whammy, if you will. And I think many of you know that, for example, in dealing with disc problems, what's the big issue with human intervertebral discs? They don't get much blood supply. In fact, they get almost no blood supply. And that's why truck drivers, for example, right? It used to be thought it was like the bounce, but it's actually a element of vibratory factors that in fact create a setup for why the human intervertebral disc fails among truck drivers. They are right up there among statistically the highest population that has lower spinal disorders, for example. Go ahead, Russ.
Is any entity incorporating or trying to incorporate the energetic effects, infrareds, the frequency that's given off of machines? I mean, are they just ignoring that elephant in the room or whatever?
Tomorrow when we talk about what triggers my response is the laptop. for example, laptops are now considered one of the issues in male impotence, or sperm counts, for example, because of the heat. I mean, literally the heat to the genitals. That's a factor, and it's not being ignored. The other one, of course, for all electronic equipment is the EMFs, right? Electromagnetic frequencies. So your question, yes, Russ, it's another environmental stressor, right, that our ancestors didn't have exposure to, which affects our physiology.
Are like actuarial science people calculating into, or is it not a tangible thing yet?
It's not as, in the practical world, I don't think in the average workplace it comes up much. However, yeah, there's some very serious science that are looking at this, although it's very controversial, as you know, you follow the money in terms of American industry, in terms of saying, is this safe or is it not safe? You know, and it's always has to kind of meet a certain standard. It's kind of like, you know, maximum, how much mercury will they allow in our water supply, or how much fish you can eat, or all this stuff. Same kind of thing. Very, very controversial. And a lot of that research is, I think, tainted. At least that's the assumption. And again, for economic reasons. If it were purely objective, I think we would be probably in a different kind of set of, you know, current circumstances. I think some scientists maintain that cancer, for example, I've heard expressions stating that 85% of cancer is environmentally induced. So put that in perspective, folks. And of course, it's usually a combination of, it's multifactorial, right? And of course, if you have multiple exposures, that's what we're talking about here, right? If you have one source of vasoconstriction, that's one effect. But if you add to it, it's layers, and then ultimately the system fails. So, and then as we talked about a moment ago, that you know, why you guys are such a natural for this is that currently, statistically across the board, and this includes the entire sedentary workforce, if you will, which we're going to re-term when we talk about it tomorrow. But that's still the commonly used expression, the seated worker. Even among that population, 60 to 70% of all workplace, and it results in 90% of the costs. So again, where is the chiropractic community when you think of it that way, right? I mean, my goodness, this is our specialty, and yet it's not being addressed in the way in which Don and I feel is more deserving than the profession has responded to. Go ahead, Jeremiah.
I'm just curious what's considered a cold environment.
Yeah.
On a tour of one of the plants that I went to, I was uncomfortably cold. I obviously wasn't working, and I was cruising around on a golf cart, but I was just curious as to what, you know, if there's a temperature range that's...
There probably are, Jeremiah, you know, in terms of like if one were to consult an industrial hygienist, I mean, that's a person who looks at the environment, like say, they would be responsible for like noise and lighting and heating and cooling and microparticulates in the air. But of course, what are the ranges of acceptable cold exposure? You know, like with hand tools and or working in and out of refrigerated, you know, environments, those kinds of things, like meat workers. I mean, meat packing. I mean, that's an environment where they, you know, for microbial control, they have to keep it like a refrigerated environment all the time. And so, you know, you got to think of, you know, that's not going to fit everyone's, you know, like a lot of people will be notably stressed. And you can only, you know, see part of it, you say, well, why don't they dress accordingly? Well, yes, however, then you lose efficiency. And, you know, like the use of gloves, we'll talk about that as an example. So I think there are, Jeremiah, I'm not conversant in it though, but I think it's reasonable. It's a great question. But I think it's pretty broad, quite frankly, because again, it's of necessity. And there are certain workers that may find it, they just can't handle it. They have to, you know, seek out other employment as a result. So this is kind of like the main issues that we will be facing on a regular basis as consultants, you guys. If you can eliminate these hazards, you will have come a long, long way in addressing the needs of the average workplace. Let's just say it that way. And it's therefore, you know, as we pointed out before, it's again additive though. So you can kind of think about it. And then of course from a clinical perspective, this would be an example. It's called vibration hand, white finger syndrome. That's how they refer to it in the occupational health setting. Of course, clinically, what's another name that we know it as? Raynaud's phenomenon, right? And of course, has a strong neurological consideration again, right? So we always want to kind of put it in perspective that way. That yeah, you know, over time for individuals, if it's neglected, you know, obviously that's what gangrene is all about, right? That's what diabetes can do, right? It just, you know, it really ultimately starves the, you know, circulation to the body parts. So this is where we mentioned nicotine. It's that effect has to be added, and therefore your line of questioning to the patient that you're dealing with, it's a critical component. Then what else within the workplace do workers have to contend with? Obviously noise. You could say, well, sound, but you want to think of racket. You know, when noise becomes a source of irritation or disruption to, shall we say, your comfort zone. And it may be variable, it might be, again, a range, but and it's measured in decibels, and there are means by which you can accurately determine this, right? In fact, a little bit later when we talk about hearing protection, this will come up again, so we'll just address it then. And lighting, you might think, you know, usually it's like an environment that would be too dark, but obviously glare is another significant issue, and particularly when we think in terms of close work, meaning by close work where you have to have a lot of light. So both of these have to be addressed. Air quality, including obviously the exchange of air, so ventilation is really critical. And heating and cooling again to the comfort level that, you know, people will usually find optimal environments in. And then the exposure to cutting tools, cutting equipment, anything having to do with cuts, lacerations, abrasions will be, you know, pretty common in a great many work environments. Odors, fumes, and gases, floor surfaces, stairs, ladders, and scaffolding. Slips, trips, and falls, I think it comes up later too. It's mentioned 23% currently of all time loss workplace injury involves a slip or trip or fall. Many involve serious injury. I think you don't need to write that down. It's in your notes a little bit later, but it's a very real issue. Chemical hazards, heavy metal exposure, electrical hazards, microbials, pathogens, fire hazards, explosives, radiation hazards, caustic exposures, hazardous weather conditions. Say, hey, I'm a chiropractor. What do I know about this stuff, right? But that's okay, folks, just so you realize that it's part of your challenge, not the most important part, right? And again, so there's the team effort. Now this one is one that's probably least appreciated in terms of what management understands ergonomics to be, because we said ergonomics is what? The study of work laws. That means it's all-inclusive, right? Clearly, without question, this issue, right? Conflicts between workers and their supervisors as a stress factor is of primary importance in the causation of workplace illness, accidents, and injuries. And of course, what is the main reason? Well, I think any of us, you know, all of us, most of our stresses as it relates to relationships, you know, maybe more domestic. You know, when you're in a major issue, a domestic issue with particularly the people you're closest to, right? Usually spouse, children, those kinds of conflicts, folks, what does that do to us, right? And can we be at our optimal level of concentration on anything we're doing? We lose that, right? And that's certainly the issue here, particularly when there's a threat that goes beyond that, right? I mean, a domestic issue is one thing, but if your job is at stake, right? If you reach the point where you're simply saying, I can't cope anymore, but I've got kids to feed, I've got family to, right? You got all these conflicting issues. How does that affect our physiology, and does that predispose us to the potential for injury or illness? And by the way, this idea of, you know, the theory, are some people accident prone? That's an interesting question, right? Because sometimes it seems that way, right? And what they have found, what studies have shown, and there's been a lot of work. On that note, Brad, this is one of the things that Liberty Mutual has done a lot of studies on. And Dr. Stover Snook has been, you know, one of the premier scientists in the world who has looked at this question of accident proneness. And then near misses, that's another category of, when something was so close to having been a disastrous event, and then they foresaw it and they were able to prevent it. But then if that starts to happen commonly among certain workers, again, that's what they start to look at this question. And then, of course, they will say, well, it's their inability to focus. Their focus of attention has been now distracted to the point where they are vulnerable. And so this can be a sensitive topic area when you're dealing with the employer, right? Because if they are the source of this kind of stress among their workers, some employers just become jaded. They have an attitude that their workers are all a bunch of, crybaby bellyachers, moaning and groaning and never satisfied with anything we do. And then they've got these injuries and they think they're being, like the idea of malingering, right? The idea of people who are playing the work comp game to get out of work and go deer hunting, this kind of stuff. Attitudes on the part of the employer is a risky thing. And of course, sometimes there's a legitimate basis for it, right? So that's where it has to be cultivated. But realize how important it is, to the tune of 50%. I mean, that's half of the potential of success. So you can't ignore it, you guys. That's my point. I really have to stress the importance of this, because it often isn't even mentioned in ergonomic manuals, right? It's not, but it has to be. It has to be a clear consideration. And as logically one would expect, it's combinations of things. Usually we can handle a lot of stress, right? Humans are extraordinarily resilient. But there is a point at which, right, we're stretched too thin and finally the mechanism fails. And it's a wide variety of factors that have to be considered. So cumulative and additive negative effects. And then, so you have to think in terms of, there's a huge population, in terms of the workforces that are out there. So all occupations where one or more of these stressors exist, obviously such a list of occupations would be, virtually, unlimited. I mean, I can almost think of none that would be exempt, except that statistics would show that these are the most vulnerable. And when you see these, there's sort of an axiom you can express and think about from the standpoint of the business perspective of this kind of work, you guys. And that is this: the greater the problem, the greater the opportunity, right? The greater the societal challenge that, is faced by the American employer, well, then the greater the opportunity is for people who are willing to take it on and say, well, we think we can make it better. And so when you go up and down the line, as we touched on, at highest risk, statistically, again, is meat packers. In fact, we talked about OSHA. Some of you know about the John Morrell plant in Sioux Falls. I think they may have one of the highest records of OSHA violation discipline in the history of OSHA, and something to the tune of maybe between $4 and $6 million, like violation is what they were fined, and ultimately they took several years to finally get it settled. But I know that at the end of the day, they had to set aside specifically $250,000 within their budget to rectify and make restitution. $250,000 was set aside specifically for ergonomic improvements for the workers in a meatpacking facility. Now, what kind of exposures are meat packers? We touched on it a little bit earlier, right? They're in a refrigerated environment, working at like 41 degrees or whatever. Might vary a little bit with different stations within it, but obviously much of it. I don't know if any of you have toured a meatpacking plant. We were touching on that a little bit earlier. And it is probably one of the most arduous kinds of work environments that I've ever personally experienced, and having opportunity to take a critical look at it. But if you haven't, I would say put it on your bucket list, because if you then realize why you studied hard and stayed in school and realize that, hey, shoveling manure on the farm wasn't so bad after all, if that's where you grew up and motivated you to maybe move out of that environment, well, so that's an issue, you guys, really understandably. They've got an extraordinarily high level of exposure factors, okay? including odors. Let's think about that. Including that everything is slippery. You can't walk without hanging on. It's laden with grease, if you will. And if you think of the, the expanded considerations involved with that, and everyone, of course, is working with gloves. And everyone, therefore, has the issue of a slippery environment, using a rubber glove and hanging onto a tool. Think of the amount of extra force that's required. And what if your tools aren't sharp, right? For example, and go on, it's just pretty obvious. Again, another neglected area for decades, literally, is this next one, nurses and nurses' aides. Here again, we're talking about material handlers, right? Because most of the rest of these will be involving a certain level of material handling. So, but if you think of nurses and nursing aides, and now if you put into the sort of the equation of say a 260-pound stroke victim, a male, 6'4", 260 pounds. You've got two aides, and this is, as you know, entry level. And usually one is from Mexico recently. One might be from Vietnam. Each one weighs 102 pounds. And this man weighs 260 pounds, and they're going to transfer this person more than their own body weight, and doing that repeatedly. Oh my goodness sakes. So think about that, you guys. No big surprise that they would suffer incredible, significantly, statistically high levels of particularly spine-related problems, but shoulders and knees and all the other factors too. And then, of course, manual laborers, the traditional American factory, and it's pretty much worldwide. Janitors, cleaners, truck drivers, as we touched on earlier. This goes back to the low backs among them as a subset, because when you think of all of the body parts, the truckers, if you were to look at just low back issues, are higher on this list. So just kind of think about it. Stock clerks, that's people that are involved in warehousing, if you will. And of course, all of the retail environments, the big box stores, anybody that's involved with that. Delivery service drivers, think of UPS, FedEx, they're literally making a living lifting on a continuum, plus they're in and out of cold environments, and anybody that's above the Mason-Dixon lines 5 months out of the year are going to be in and out of cold and hot on a regular basis. And of course they're vibrating all day long in their trucks, right, their vehicles. So multiple factors. Construction and building, by the way, is really related to a lot of fatalities. Did you know that there are 6 American construction workers killed every single day in this country? Yeah, it's really huge. And tragically also, I should mention, because again, it doesn't come up in the statistics, there's another population. Anybody want to suggest who that might be? You can imagine construction workers, right? How about farmers and ranching? What's interesting about that is that they're not in the OSHA statistics because they're family-owned environments, and usually, those data, but if you look into those data, tragically, 6 American farmer or members of farm families, and tragically one out of every 5 is a child under age 15. And think about that in terms of fatality, the danger nature of working in a farm or ranch type environment. Retail sales, warehousing, storage, maids, hospitality workers, obviously law enforcement, police, they have a unique situation along with firefighters, right? They may sit for 3 hours in their vehicle and doing zero, right? They're completely static loading. And then they have a burst when there's a crisis and their sirens are blowing and whatever. But you can imagine homeostatically, right? Anything that threatens homeostasis, these guys have a very unique kind of exposure factor. Assemblers, here we have a lot of repetitive microtrauma. They may not have the severe blown disc issues, but they have tremendous potential for repetitive microtrauma disorders. Fabricators, the same category. And that number 16 is why I added this, because often the data are not readily available in terms of, because they're not part of the regulated occupations. By that, the word regulated would mean that somebody's looking over their shoulder to meet a certain safety standard, i.e. OSHA, right? And on our last session, during the third session, when Dr. Hendrickson and I provide that training, we'll be talking more about, these governmental regulatory bodies and how the consultant needs to be aware of, and then also make, or help the employer to become as optimally aware as possible to keep themselves out of these kinds of problems. So then again, looking at why would we be engaged in this work, folks, what kinds of outcomes should be expected? Some of the benefits, obviously, there should be a reduction in fatigue. Remember we talked about energy expenditure. So if you have a workplace environment that is ergonomically properly designed to reduce energy loss, well, that's going to contribute significantly to having some energy left at the end of the workday. Reduction in pain and discomfort, broad health risks of every category, accidents and injuries, cost factors, worker turnover. Those are some of the obvious, things that would be reduced. Now, what are the other elements? These would be increased. We want to increase worker productivity, improve their quality of their output, the quantity of their output, improve worker morale, worker retention. Do you think worker turnover rates are an issue, folks? That's called an indirect factor. In terms of the total cost of, say, the work comp burden for employers, worker turnover is a huge one. And in fact, it's an indicator, by the way, when you're doing your assessment of their needs, you want to be really cautious to place high emphasis on worker turnover rates, because that means they are spending a lot of money on hiring and training, and also on the mistakes of new workers, and on and on. There's just a huge component that includes, obviously, worker morale. Because if there's high
I just want to reemphasize the point you're making here and put it into practical sense. A company that I've worked with in the past, their training process, so that every time they had to go hire a new employee because of internal situation, they invested about $6,000 in training that new employee at a $10 an hour job. So you can understand the importance of that worker turnover. Keeping good employees is very important for them.
Once a company has a reputation, folks, it's no different than your work, right? I mean, attracting good employees is another question, right? So just kind of realize that the word is out on the street, right? Where do you want to, engage and contribute your life's work? You clearly, want to put that in perspective and how valuable you can be to help the employer to understand the significance of what we call the indirect factor. Why is that so important? Because it's not a line item budget item, you see. It doesn't appear in their annual budget. Direct costs are, they know exactly how much work comp premium, right? They know exactly all of that, and they can predict and calculate and create a business plan. It's really difficult to do that, though, with the indirect factor. And these are some of the sources of the indirect factor of the cost of workplace injury and illness. So, worker morale then. Okay, worker retention, improved labor management relations, kind of the effect of that. And do you think ROI? You'll see that quite often, you guys, and you might just see the acronym and not really kind of immediately think of what that means. But return on investment is an absolute. You got to remember, folks, when you're talking to the corporate world, these folks are usually well trained in the business world, and so the concept of talking about money is going to be extraordinarily significant. Our recommendation, though, and you guys may remember, we would say, don't bring it up. They'll bring it up. If you come on to them with the notion that you're going to be some kind of a hotshot, whatever, actuarial, accountant, you're going to save them all these monies and that's why they should engage you, we're going to say, folks, they're going to misinterpret who you are. We recommend you go in with a white hat and a white coat. You're a do-gooder. You're only interested in human suffering, unnecessary human suffering. Let that be your message, folks. Don't come in as if you're going to be an economics expert, because that'll translate, right? These guys, they have money for breakfast, money for lunch, and money for dinner. That's what they live by. But it's not your expertise, so don't let it pretend, don't pretend to be what you're not. It's my sort of simple message about that, you guys. Just kind of keep that in perspective. They will translate that for you. If you can, do these things for them, right? Click, 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 it immediately makes a great deal of sense. So how about that last one? Again, don't, Carmen, Don, don't. So what is the Hawthorne effect, you guys? Anybody? Now don't look forward in your notes. You can go ahead. What does it imply, folks? This is the concept of the worker perceiving that management cares. It's the equivalent of the placebo effect. And it has a significant importance. So kind of keep that in mind as to when they bring on a chiropractor as a benefit to those workers, would that not be a component of what the effect may be? And should you play that card? I really think it's an incredibly important card to play. Makes sense, folks? Because again, management is doing this on their behalf. And of course, it has to be interpreted that way. At the end of the day, you guys, if you're going to be successful in this world, you have to get those, first of all, you have to get management to understand that you're there for the worker. And management has to allow you to be there for the worker. If the worker perceives that these activities are being done to them, rather than with them and for them, it's going to boomerang. Right, folks? It's just another management ploy. They got this doc that's in their back pocket. You see the idea of a company doctor? One of you, and I understand why, but one of you used the term company doctor. Let's say in this environment, you guys, we're going to discourage that term. Don't seek that idea of becoming a company doctor. Why? Because what we're talking about. Workers will what? Immediately, you're going to be suspect. Generally speaking, workers don't trust, therefore respect, admire, or in fact, want to be compliant with the company doctor because they think that it's, especially that's why you may not be, shall we say, eager to think in terms of becoming a full-time doctor within that company, because then you will be labeled, right? If you're a consultant, if you're there as a person to facilitate workplace health, wellness, and safety, and you're a wellness specialist, or all those other, whatever term, coordinator of health, wellness, and safety, doesn't that sound better than the company doc? With all of its societal connotation? That's my point, you guys. You want to be cautious about that, right? You want to be sensitive to the potential that those workers would interpret that as what? Do you know what the opposite of placebo? Do you know the term? You know, nocebo means noxious, meaning the opposite, negative. It could have a negative, an absolute, a reverse of what your intentions are. So kind of think about that as well as we think of this Hawthorne effect. In the biological and the healthcare sciences, everybody would realize the placebo effect is at least something is happening where the patient thinks that it might be something good. And in fact, it's pretty remarkable. You guys know that in the biological and in the health sciences community, it's considered about a 30% factor. If you did nothing, you would have about the same effect, right? If you simply were there and did nothing, it may be up to a 30% difference in the outcomes, just your presence. So just kind of think, I'm going to do this, then we'll take another break, you guys, because this happened at a Westinghouse facility back in the 1920s. I don't know which community actually, how it got the name Hawthorne. It was one of the things I intended to do, go on the web, and you can do that anytime you want to, but I'll give you this scenario, where it all began. Let's say we were, and in fact, this room would be right down this line. We have this group of workers, and so one morning, this elderly gentleman with white, probably long hair, with very thick glasses, comes in and talks to this bay of workers. Well, now, ladies and gentlemen, we finally have figured it out. We understand now why your productivity has been lacking. We understand that it's the glare. There's too much light in this room. And so they unscrewed every 6th light bulb. So then he went to this bay and said, well, now, ladies and gentlemen, we're very excited to tell you that we now have figured out why the productivity has gone down in your department over the last year. And we realize now that it's too dark. And so they've added an extra light bulb. And at the end of 3 months, what happened, folks? Productivity in both departments. That's called the Hawthorne effect. It had no real basis other than perception. So just to use that, hopefully this will help you to remember it, going through that silly little scenario. And if I were to underline a term in all of these notes, you guys, and maybe put a couple asterisks by it, it's this word in the world of particularly the biomechanical aspects of ergonomics. Obviously, chemical hazards and caustics and radiation, that's another story. But in terms of the biomechanical components, the neuromusculoskeletal components, obviously adjustability is absolutely key. And I think again, why this is such a beautiful thing, folks. Why? Because it helps us adapt to the workplace challenge, right? If you can more successfully adapt your physical circumstance to the workplace challenge. So I think you remember in the original premise of homeostasis, right? Why do people become ill? What is the cause of illness, by the way? I think in chiropractic circles, we used to say there's really only one cause of disease. Does anybody remember that from our classes together? You got it, John, right? The organism's inability to adapt to its environment. That's why we get sick, and that's, of course, why we die. And, of course, if we don't adapt, what happens to the species? Right? It goes extinct, right? Adaptation is the key, right? So, of course, this is one of the means by which this can happen. So, and of course, what's so unique about this as it relates to the chiropractic community again? What is the principal regulator of homeostasis? Is it the muscles? Or do you think it's the brain and the nervous system? Right? That's my point again, you guys, right? What facilitates? So if you only had one word to answer what is the cause of disease, you may remember that too, John. I used to tease you guys about that. Stress. Stress, right? But of course, stress is not your argument with your mother-in-law. Yeah, that might be, but we're talking about all these things we've talked about so far, right? Stressors. Anything that can disturb homeostasis, right, can set you up for failure of the mechanism, failure of the system, inability to, be able to survive, if you will. Survival is the driving force, right? You guys know that. Ultimately, that's the whole principle of maintaining homeostasis. So all of this background that you already have and your awareness of, keep that in mind as you look at the worker and what they're exposed to on a daily basis. So examples, as we said in the biomechanics world, adjustable chairs, monitors, keyboards, work surfaces, tools and equipment and whatever. The ability for the worker to have control over their own environment is huge, again, from the morale perspective. But these would be examples. You see these are, it's the same machine, but you see her height compared to his height, and then the work surfaces, and so of course these are adjustable work surfaces, so to speak, to accommodate to their individual needs. So looking at that question, most routine tasks for normal work surfaces, normal, that would mean, again, non-stressful, meaning like typical light duty kinds of activity, should be adjusted to just below elbow height. And then heavier work, it's classified heavy work about 8 inches below elbow height. And then for very precise work, the surfaces should be actually raised slightly above elbow height, as they would talk about close work. Think of a seamstress, right? Or think of doing, like if you're wiring like microchips or looking through, doing the things that are often required of assembly. So this diagram will help you to, kind of get ideas and perspectives. What's unique about this, of course, it assumes that these workers are all the same height, and that will not be the case, of course. So that's why we have to think in terms of what you are observing here. Obviously, this person might be 5'10", and this person might be 5'2", and therefore this is a means of a low-cost intervention that could make all the difference in the world. And would you say maybe a shoulder disorder or a recurrent elbow problem or a neck and headache problem or so on. So then in the big picture, what do we do? What can be done, and how does management make priority decisions based on what has shown to be of most value and effectiveness in terms of intervening, in terms of the prevention of workplace illness and injury? So they're in these categories. The first one, of course, is the logical one. I think everyone would realize the importance of personal protective equipment. And virtually there's no work environment now. Much of this, by the way, is regulated through OSHA requirement, right? Common sense. But of course, one of the most common violations is, of course, inattention or lack of compliance or whatever to these considerations. But anyway, personal protective equipment, administrative controls, engineering controls, sometimes substitution and or elimination, which are the less common, but we'll talk about each of these. Called the hierarchy within the control interventions category. And you'll notice this interesting kind of inverse relationship, right? You'll notice the easiest to implement, partly because it's OSHA regulated, right? Easiest to implement is personal protection equipment. However, at the end of the day, the end of the quarter, the end of the year, it also has shown to be having the least effectiveness in terms of actually changing statistics of reducing injury and illness. So then, going up this, if you will, the pyramid, the administrative controls next, then engineering, substitution, and then elimination. Harder to implement, obviously, but it will be the most effective. So kind of consider that. So we'll talk about each of these a little bit. Some of the, go ahead, Russ.
Like the football helmets, that they give a person invulnerability?
Well, I mean that.
They have something that, so they aren't as cautious, or they're...
No, I think most of it in terms of personal protection equipment. For example, in hearing protection. If you go into a work environment and you see maybe in a department that might have 60 workers, and they all have the same exposure to the noise. Why? Because half of them are wearing their earplugs, but the other half aren't. So what does that mean? Well, obviously it's a high-risk noise environment, and therefore the requirement is for everybody to be wearing their earplugs. Well, when you got earplugs in, though, what's an issue? You can't hear each other, right? And in fact, that's another trade-off, right? So compliance, I would say, more than any other thing. But, like simple things, a hard hat and the glasses and the gloves, that'll vary proportionate to what kind of exposure people have. Here we see, for example, safety shoes, steel-toed shoes, the shock mat. Shock mat, though, is probably optional in the OSHA environment. It's kind of like, a luxury. It isn't required, and therefore a lot of employers, even though you're on cement floors day after day, the shock mat is thought to be not very important. So, but it's an example, right? So compliance is the issue, but we said it's the easiest to implement, mainly because they have no choice. But of course, workers, the compliance is not always there. And so that's another issue. And if the employer doesn't have a zero tolerance issue, that has to be a policy for zero tolerance for non-compliance. But do keep that in perspective. That means that somebody's going to have to enforce that. And if you want to be unpopular with your workers, you're going to be on their tail. You're going to be on their case all the time. What does that do? It's morale issues and on. And so just know that, you guys. It's there, and a lot of it is, obviously it's critical, and it's probably saved, in work environments, obviously it's saved a great many things. But so the next level in that hierarchy, as we said, is administrative control. So what do we mean by that? How is that defined? So obviously training is a really critical component, and it's just incredibly important to recognize and understand, as Chad pointed out, the hiring. Chad, did the $6,000 include the training? Hiring and training? You spoke of hiring and training of the new worker was the cost for a $10 job of $6,000 per worker. So if you have a 20% worker turnover rate each year, put that into the budget, folks, right? It's just incredible. But therefore, do you think some employers are rather lax, rather casual about the training? Oh, you've been here 3 days already, you should know your job, right? And to that end, and of course it has to be very specific. It can't be generic, it has to be very specific to the individual job. Conditioning could be extraordinarily important in given situations where there's a lot of physical demand, of course. Job rotations, do you have a sense for what that means, you guys? Where the person doesn't use the same muscle groups day after day, hour after hour. Many people, savvy employers, there's a trade-off here though, unless it's a union shop, that's where you're going to run into problems. If it's union, you do your job because it pays $2 an hour more than this guy's job who's working right next to you. Doc was just talking about that in a personal situation that he had. But in most cases, what you want to encourage non-union shops, and by the way, unions, do you know the data on this, folks? What was the, when you think of America and you think of all of the publicity that, say, the AFL-CIO, and think of Jimmy Hoffa, and you think of the auto workers and the electrical union and all of this stuff, what percent of the American workforce at its peak was unionized? Anybody want to give a shot at that? It's 22%. Only 1 out of 5 people were protected under some kind of a collective bargaining situation. And then it's decreased profoundly and dramatically since then. Right now, Chad, is it something like 8%?
I know that it's below 10.
Yeah, it's just amazingly, like now only 1 out of what, so it's not nearly the issue that it once was. And again, administrative controls, and here we say the very first one, there's a caution. You see that used wisely, worker incentive perks. One thing we really stress, you guys, is to have management understand the dangers of setting up rewards for so many days without a reported work comp injury. So what does that set the stage for? Delayed reporting, right? And that means you keep living with, and pretty soon the tendonitis is so great you can't you can't operate your hand tool because now you've got a full-blown disabling tendonitis because you should have sought attention earlier. So, but somebody's going to lose the $50 at the end of the pay period because they went another so many days. Do you get the idea? If management doesn't understand how dangerous it is to have those kinds of incentives, they have to be used really wisely, and you have to be attentive to that. Be aware of the potential for it being absolutely a negative effect and may in fact be contributing to problems. Here's where we talk about the shift work, you guys, avoidance of short shift work schedule requirements. That would mean that a 6-week, you're working nights and then you go off and work days for 6 weeks, you're setting yourself up for big, big problems, you guys. And by the way, if you were to examine this, the effects are broad and serious, including cardiovascular, respiratory, psychosocial. There's a whole list of serious potential problems associated with shift work. However, some people relish it. They would much prefer the night shift or whatever. I mean, for any number of their own personal reasons. So if management can understand that and help them to understand that given them the choice, we would say, well, we run 3 shifts, but we also are very selective regarding the workforce. One thing we clearly do not want to have is these short-term turnaround points. There's a variety of physiological effects. One of the examples of this, you guys, as the airline industry. You know, they often will work 8 days on and 8 days off, for example. And then you've got crossing the time zones. So pretty soon, females, for example, their whole menstrual cycle gets disturbed because, again, they're living in, you know, different time zones, and so that's one of the occupational groups that's, you know, an example of that. But many factory environments and whatever still run 3 shifts, and of course that's always part of what management thinks is another mark of success. But one thing we put a great deal of emphasis on in terms of the OSHA log, and you guys know what we mean by the OSHA log, Ocean 300 log it's called, and that's a mandate by the corporate, OSHA requires employers to keep an accurate record of every incident. That's called a recordable or a reportable. We'll be talking more about this in the last session that we do together. But in that process, you guys, the element that we want to be, you know, asking you to be thinking about is the who, the what, the when, the where, the how, which workstations, what time of the day, what shift of the day, all of these components in terms of the specific injury. And if you see a trend, and if you have a lot of overtime, for example, and you see that, you know, that 30% of the injuries occurred within the first 8 hours, but 70% of the injuries occurred in the last 2 hours, that means you have to consider, is the overtime worthwhile? You may be gaining in productivity, but you may be losing it on the other end because you have a higher incidence of injury. You have a morale factor. You have a variety of factors, right? Same thing with these 4-day, 10-hour shifts. You have to be sensitive about that. And now nurses are often doing 36-hour shifts, right? They're doing 3 12-hour shifts. And of course, they say, well, you don't even have to work a full 40, you're getting paid for whatever. Bottom line is that there may be trade-offs in this, and you have to be sensitive about it. It's all part of, you know, this consideration. And then, as we talked about earlier, this zero tolerance. Obviously, supervision. Usually, this is it falls to middle management, right? The middle management folks, by the way, are you aware they bear the heaviest stress load of all occupations? Middle managers, they're right up there with air traffic controllers. You know, when they measure different occupations and the stress level that they endure, I think air traffic controllers are really, maybe they're the highest level, but really up there with them are middle management, and partly because they have an incredible amount of responsibility, and they have, in many cases, very little authority. That's an unfortunate reality, and so they're kind of caught in the middle. And so the discipline of workers is there, that's what's expected of them. But as we said earlier, lack of supervision. Poor housekeeping is a critical element, like we talked about, slips and trips and falls. Most of those do not occur on scaffolding or on ladders. You'd think, well, that's what we mean by slips and falls. But in fact, it's on level surfaces. But poor housekeeping is a significant issue. This is a really significant issue as well. And I think recently that came up a little bit, Chad, when we asked this question about might there be some racial, ethnic issues between and among workers. And if middle management isn't sensitive to that and allowing that to take place, it's kind of like bullying, you know, in the playground, same kind of thing. If middle management doesn't, you know, have a zero tolerance for those kinds of things. This one we touched on a moment ago, nepotism. Tell them your experience, Doc. Thought it was kind of unique when you talked about it, because I said, well, that's another issue, if you're willing, with your father-in-law, or your stepfather, you said.
When I was in college, I got the opportunity to work in industry. Of course, my stepfather was the plant manager, and I overheard your conversation. But the first day I went to work, lunchtime came, and I went into the office and washed my hands and sat down and sat next to my mother, who also worked there, and was having lunch. And my stepfather walked in and said, "What the hell are you doing?" I said, "I'm having lunch." He said, "No, you're not in here. You have to get out there." He said, if you stay in here, you'll never get the respect of your workers, and never talk to you or whatever like that.
Mm-hmm. there's that joke. It was during the Kennedy administration when John F. Kennedy appointed his brother Robert to serve as the Attorney General. And then I think the sort of like feedback on that, I think it was Robert who said, well, nothing wrong with a little nepotism as long as you keep it in the family. So, yeah. So that's an issue, folks, right? And that happens. We notice that too in work environments where family members or cronyism, they get perks, they get favors, they get whatever. And of course, other workers resent that, and that's where the morale issues are a really serious thing. Again, there has to be zero tolerance. Horseplay is another issue, and it's kind of generic, but this is something you want to be particularly attentive to with regard to new workers, young workers, and who usually gets the crappy shifts. New workers, new hires, and of course the younger ones, because the journey people have earned their right to have a day job, right? So the bottom line to it is that in most cases night shifts have fewer supervisors, right? Same thing, supervisors. By the time you get to be a supervisor, you don't want to be working nights anymore. You got family, you got, whatever. So it's kind of like a bad equation, right? You still need, again, a really important attention to managing, particularly as we say, this idea of horseplay, which sets the pattern for the potential for injury and illness, of course. So now we shift to engineering controls. What do we mean by that? Well, obviously you can modify the workstation, right? Just like we touched on, a couple of examples already, tailored to the individual worker's needs. So from the group of, Hmong workers, that would be an example of this, simply providing them with the means by which they can, modify their work environment. And of course, it could include reducing environmental stressors. For example, noise abatement would be an engineering control. And there are certain techniques to go about doing that, and so on. So, and then updated ergonomically designed machines, hand tools, and lifting aids, availability of optimum protective gear and other things. So again, there's an axiom that we'll touch on a little bit later. And it says power with motors, not with muscles. So that would be an engineering intervention, right? So you can use, equipment designed to do that, providing tools that are designed to allow the wrist. You can see, you guys, this is called a neutral wrist. We're going to be talking about load moment. We're going to be talking about, maintaining the body's mass over its base of support. And there's some basic concepts surrounding that. And of course, to engage, invest in these kinds of tools and machines or devices that are, this one happens to be kind of unique in the sense that the greater the load, say if you have, let's say if they were cement, 94-pound bags of, in those Portland cement, well, if you have, 6 of them, it's going to settle lower, right? And of course, the more bags that are removed from it, of course, then it's going to come up, usually, again, within this, what we call the power zone, which we'll talk about a little bit later. But that's kind of the notion of providing all of these kinds of devices, but they don't come cheap, right? And therefore, it's a commitment on the part of management to say, what's the trade-off? If you prevent one spine-related injury, what is the current? This is something like $36,000, I believe. Is this the direct cost? And that's the average. I mean, it's like mind-boggling, you guys, when you consider, how many cases of low back problems that we treat for probably, 20% of what is the average. Just mind-boggling why we're not more in the mainstream of occupational health, folks. It's just, but again, there's a greater and growing body of very positive data that are supporting who and what we are, and we're using that to good advantage in talking to employers. Hopefully we can make some of that data available and remind them where they can obtain it, Chad. We might consider that in terms of getting some hard copy at least of some of the data. I know Elizabeth has some of that available through the Academy. Finally, as an intervention strategy, we can look at the concept of substitution. And that would indicate a decision on the part of management to substitute the methodology of a high-risk task to a process that poses less risk to the worker. And so it's a substitution. It's more difficult to accomplish, however, since it could result in what? You have to look at it. More steps, less efficiency, more workers, higher costs, right? So, you know, it's usually not going to be their first choice on the part of management to do this because it could slow things down, reduce, you know, output and on and on. On the other hand, you know, it reaches a point where if it's going to prevent even a single injury, it may be to their significant advantage. And that's, of course, where you guys come in. And then finally, elimination. As the term implies, elimination would mean that senior management has decided to completely eliminate a particular process or task because it's simply too dangerous or it's too stressful. Again, they may have had experience. They've decided now we've reached a point where we just say we have to stop doing it. It's been too dangerous. Or consider this, you guys. It could mean that management has decided to eliminate the risk to humans, right? The job still is going to get done, but we're going to put machines to the task. And this might be where now we decide to invest in robots, right? You can kind of understand that. That would be eliminating the human exposure. So I think you can kind of see when and where that would be applicable. Now we're going to go to some sort of time-honored considerations in the world of ergonomics. These are recommendations that workplace design should be respectful of, and all workers should be properly trained to heed them in the interest of preventing workplace injury and illness. So the first consideration we'll talk about is the idea of load moments. And on the first sort of like exposure to the term, it might seem outside of your, you know, like day by day understanding, but in a moment it'll become really clear. So while either sitting or standing, all forward-reaching tasks beyond fingertip reach forces the trunk into a flexed position. Flexing from the waist or the femur heads always results in the creation of a load moment at the lumbosacral junction. So this is what we mean then. The concept of a load moment is a simple engineering term to define that point in space where a vertical vector and a horizontal or semi-horizontal vector meet. Let's phrase it this way, you guys. The most efficient loading system is one without vectors, right? The load is simply following a perpendicular to its base of support. Anytime you introduce, right, a vector that deviates away from vertical, that means a horizontal or a semi-horizontal vector, that point in space where these two forces meet is referred to in the world of mechanical engineering as simply the load moment. Now it's got further definition, which will become very real to you, I think. As you can see this now, you guys, you can see that it's variable proportionate to the extreme of the load moment, but you'll see workers in this posture, well, more often than you'd realize. But of course, these would be, you know, additional examples. See, in this case, there's a lesser load moment, right? I mean, if you figure the force of gravity, here's the base of support. In the world of ergonomics, by the way, there are three constants. The first is called gravity. We live in this field of energy called gravity, right? And the other, of course, is the horizon, right? A level surface, so it's a perpendicular to a horizon. That's the second constant. And then the third one is what we refer to in the world of ergonomics as our base of support. So where's the body's mass in relation to our base of support? And the feet, therefore, become the base of support, except when you're sitting, right? Or when you're kneeling, or when you're crouching, or whatever. So crouching would still be your feet. But anyway, so we can look at that. Now, you see what I'm saying? How common? Well, it's more common than you might realize. People are still doing this without consciously being aware of the amount of stress they're putting on their body in terms of what we will further define. But maybe what I'll do is let's further define it, right? Keep this in mind, you guys. Cardinal rule in understanding basic core ergonomic principles. It's not the weight of the object that the person is lifting. The heaviest object humans carry or transport during any workday is the weight of their own body mass. How much? Well, I weigh 180 pounds. So now I just lifted it, didn't I? Am I not lifting 180 pounds? Now, though, when I lifted it, it took more energy, didn't it? right? You get the idea. I had to use more kilocalories of energy expenditure to move my body mass through space. Okay, now that's the point, folks. Now let's read on. It says the human body is top heavy, a ratio of about 2 to 1. 2/3 of our body weight is above our femur heads. Interestingly, we are the only mammal on the earth where this is true. Every other mammal on the earth, most of whom, of course, are quadrupeds, but by our bipedal nature, our center of mass is above our base of support. Is above our center of mass. For humans, it's about at the second sacral tubercle, which is above the femurs. Whereas in quadrupeds, the center of mass is below the femurs. Okay, so that puts us at a biomechanical disadvantage, and of course, why this is so vulnerable, right? Why the lower spine, and of course, that's a trade-off for our bipedal opportunities or advantages, so to speak. Obviously, in Darwin theory, right? There was a reason, obviously, and I don't want to get into the dialogue about, creationism, Darwinism, or evolution, but the point is that humans somehow found themselves advantageous in terms of survival by becoming bipedal, right? So, and of course, with that, there are certain trade-offs, and that leaves this mechanism vulnerable because of our top-heavy nature. Now, it might not have been the case as long as we didn't do what? Didn't become industrialized, right? Once we started to use our body in such a way that forced us into these postures on a repetitive basis and then doing all kinds of weird extremes, it's different than picking a fruit off the tree or whatever you're doing to survive before we became industrial, if you will. So let's look at this for a moment. What this means is that if a worker weighs 180 pounds, when they bend forward from their waist to raise a 1-pound object, they're lifting 121 pounds. 2/3 of 150 pounds is, 2/3 of their body mass. So of a 150-pound worker, there's that. So plus a 50-pound object that they might be lifting. So for every lift, they're exerting the equivalent of a 150-pound lift. So you'll see many, many examples of this in the workplace, and the management would say, well, that only weighs 13 pounds. That's nothing. See, it's a 13-pound lift on their job description, right? But you see the worker isn't just lifting 13 pounds. So this is what we want to be thinking about. So let's further define this concept of load moment, you guys, because it'll have application in dozens and dozens of circumstances. So by definition, in the world of engineering, it's also known as a site of maximum stress in a loading system. The musculoskeletal framework of the human body is a loading system, right? So right there, now that becomes a site of maximum stress in the loading system. So let's define it further. Think about this for a moment, you guys. Spinal subluxations most often exhibit the principle of load moment with resultant spinal buckling and loss of optimum loading efficiency. The following radiographic image examples of spinal subluxation will help clarify the point and should be of notable interest and concern to doctors of chiropractic. Does it fulfill the definition of load moment? What do you think, folks? Do you see the perpendicular to the horizontal line and the vectoring away from? So now what does that translate to become? Jeremiah, you would probably jump at this opportunity, right? That's called a buckling point, right, you guys? It's also known as, well, just more examples of it, right? And of course it can and does occur throughout. And in my mind, this is what chiropractors should be paying attention to. And when they don't, then I'm going to say you're missing something, folks. Because it's pure, solid, pure mechanical engineering is what we're saying. If you want to identify structural stress in the human frame, you better capture that, and you better know exactly. It's not one above or one below. It's like a dentist. It's not, maybe we'll get the right one if we drill all three or all four. That's my point. It really goes back to the idea of applying mechanical engineering principles to human framework, right? And do you think this is a public health concern, folks? what you are observing here, is this a public health concern? And I just feel that chiropractors have the opportunity to become sophisticated bioengineers. But somehow along the line, I just see a lot of technician activity going on out there. A very generic application of this beautiful science that I think has a great, great potential for taking another look and really re-exploring the concept of subluxation for what it is. Okay, so what else? Load moment is also commonly described as buckling point, or the site that would result in what? Collapse of the loading system if the forces continue over time or suddenly increase, right? So what do we call that then? Failure of the system, right? And of course, that's called a herniated disc or whatever else you want to call it. Bottom line to it, though, is that there is a point at which it's going to fail if the forces continue or if it's sudden, where it's unprepared, right? Now you've got a major catastrophic event in this loading system called the human frame. So I want you to kind of put some serious consideration to that, because I think for many chiropractors, this has sort of been downplayed in terms of its potential importance. Then realize this, you guys, as well. Similar to our appreciation for the negative effect of spinal buckling within the vertebral column, load moments can also occur within the extremities. Sometimes hand tool design results in excessive ulnar deviation, or radial deviation from the side, or excessive flexion or extension of the wrist should also be avoided, and it's based on this similar premise. So when we look at the idea of, shall we say, applying it, and you'll see more examples of it a little bit later, we're sharing with you the idea of applying the principle of avoiding load moments, when and wherever you can prevent the worker. And a simple example is keeping your wrist neutral, right? Anytime you do this, what do we have? We have a load moment, don't we? It's the same idea. It's a site of maximum stress. So if you stress it repeatedly, hour after hour, week, month, year after year, you're setting yourself up, which has been another source of frustration for me when I watch students and how they're taught to adjust. When they're doing this whack, 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 again, the whole generic approach to spinal manipulation, I think they're putting themselves at extraordinary risk over time, right? Because remember Newton's second law? Every action has an equal and opposite reaction. And by the way, did you know that chiropractors injure themselves? They have significant occupational potential for, overuse injuries. And so applying ergonomic principles to your own career could be really, really relevant in terms of prevention. So this is what we're describing in terms of, maintaining. Let's back up one, because I think we were talking about minimizing overhead reaching. Whenever possible, the necessity of reaching over shoulder height should be avoided. When overhead tasks are required, it's more appropriate to assign, and this is a side point on this note, you guys, whenever it's not possible to completely avoid overhead tasks, if you have the opportunity and management has the choice in the matter, considering unions and other things, if you have overhead work, it's best to assign male workers. This activity is males have more upper body strength than females. Interestingly enough, though, how many of you guys do Sorensen's test, which means you lie over a level surface and then you see how far or how long you can sustain using your trunk muscles to hold yourself out in space? Women are stronger in that. So it's like the trunk muscles, and part of that, of course, is parturition, right? The delivery of infants has to do with. So nature has her ways in this. By the way, there's another simple little anthropometric thing that I like to share. Maybe we'll do that and we'll take our next break. But maybe it wouldn't be a female, but I suspect it will be. Ladies, if you would kindly, ladies, would you kindly stand? I think you're probably going to be the shortest among the 4 women. If you wouldn't mind, ma'am, stand. And let's make a judgment. Dr. Green, is it? I think Dr. Green is probably the shortest of our female examples. Have a seat, ladies. And then what I'd like us to do, though, is I have a couple of chairs. if you guys want to volunteer your chairs, who's the tallest male in the group? Jeremiah, you're probably right up there. If not the tallest, stand up from him, Jeremiah. At least you'll serve as a good example. How tall are you? Anybody taller than 6'1"? Just to serve as an example. Well, we can maybe do a couple of examples. Dr. Green, if you could, maybe you guys could loan a couple of chairs. I want to just demonstrate something. Just have the chairs and sit them just two chairs back to back for a moment. And Dr. Green and I know you told us your name. Well, Jeremiah, you can be first. We'll probably do it with two subjects. First of all, just be stand, having facing the audience, your group, and stand back to back for a moment. Okay, so who's taller? Okay, now though, I'm going to ask you guys to sit back to back for a moment. Something change? Stand up again and then kind of get your eye, how much difference is there in their height? About 12, 15 inches, right? Now sit, and what has happened? What's the difference now? What does this suggest, folks? There's a difference in the anthropometrics. Doctor, you want to come over and maybe we'll do it again, to point out that the anthropometrics between males and females is quite dramatic, and it goes back to this principle. Yeah, once again, just compare the vertical height. It's probably a good 15 inches, would you agree? And then go ahead and sit. Because it might be variable from one person to another, but it's about the same, maybe a little bit, they're even a little closer now. What is this all about? Well, women are taller from their femur heads to their shoulders. Okay, males are taller from their femur heads to the floor. Okay, what do you think that nature had in mind? Do women need more space? Yeah, and that's what it's all about, you guys. It's part of the reproductive need for the female to anthropometrically have a greater distance from shoulder to femur, okay? Just to point that out. And therefore, in workplace design, if you have a man and a woman working together, you have to put that. Now, one last thing, though, Dr. Green, tell me your name again. Mike. Mike, if you would. Stand for a moment. There's another component. What would you think that might be? Let's have you reach as high as you can reach. Okay, now notice again this difference, but keep that in mind as you design the workplace when you have men and women working together. Because again, it will be variable to some extent between two men who are the same height vertically. Get the idea that we're not all the same. I mean, our distances, I happen to have longer than average arms than a person of my height, and my shoe size might be so on. So that's the point we want to leave with you guys, to think about that when men and women are working in the same work environment. Consider the difference in their anthropometrics, okay? Make sense? Thank you, Dr. Green. Thank you, Mark. So the symbology again of what we spoke of earlier, the concept of what your consciousness would say in terms of green and amber and red, right? So these are the postures that would be considered acceptable in the position of where we bear the greatest strength and have the greatest efficiency. This would be the amber zone, and of course anything above shoulder height, or as it approaches shoulder height, when you're working out here, you're in a red zone, a danger zone, red flag, ding, 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 not a desirable situation. And here we emphasize the idea of load moment again, right? Notice the idea of the positioning of it, the neutral wrist compared to if the wrist, and there'll be more examples of this a bit later, but I hope you can start to see the notion of designing a workplaces that are respectful of these considerations. And here the title is simply that too much in a hurry. Why? Because obviously the ladder is right there, but she's choosing not to use it. Although it doesn't look like a very sturdy ladder, does it? So maybe she's had some experience with it. And then of course the idea of exertion, you know, included with reaching, you have another combined value or an additive stress factor. We're considering that. So The dangers, obviously, you want to try to avoid reaching as much as possible. All reaching that cannot be eliminated or minimized should be positioned directly in front of the worker's trunk. Doing so prevents the need for twisting because, of course, if you're reaching and twisting, you're setting yourself up, for greater issues as well. Obviously, the worst case scenario would be where the worker is both reaching overhead and twisting their trunk to secure or to perform the job or to move the object to be transferred. And then, of course, the majority of workers' comp claims for lower spinal injury describe that the worker was bent forward at the waist and twisted. Again, that's what the work comp data would tell us. And so if you know that to be the case, anytime you spot the potential of that happening, there's a very serious consideration associated with it. And there's another concept that we would leave with you to help workers incorporate the instruction that you give them. And it's basically, we refer to it as nose and toes. So to avoid torsional type lifting injuries, workers must be taught to avoid twisting while bending. Aligning their feet with their pelvis will prevent this strain. A simple way to teach workers to avoid twisting with their feet planted is when you move your nose, move your toes. So if an object is, let's say, off to their side and their feet are planted, their logical thing would be to go to flex and rotate, right? So we're saying, but you can avoid that by turning your body, right? Avoid the twist component. You're still going to be flexing. Now, if you can raise it up, you can avoid both, right? So that would be even better. But to leave that concept with you. So here's one more of those time-honored rules. And that would mean that all the work that workers are expected to do should be positioned between knuckle height and shoulder height and not to exceed fingertip reach with the elbows flexed at 90 degrees. So basically, think about this, you guys. Elbows neutral, but flexed at 90 degrees, that's your work zone. Anytime your work zone requires your hands to go beyond fingertip reach, what happens? You now are creating a load moment, right? You're creating stress, and of course often not only at the lumbosacral junction, but also at the cervical thoracic junction. So that's a basic rule. If you can, create an assembly environment, or let's say a keyboard, right? That follows this basic premise. It's not necessarily easy to accomplish. You'll see lots and lots of examples where this is offended. This rule is not, for management, the easiest thing to accomplish, but it's the optimal, right? It's the ideal to, as close as you can get to creating this, would be the optimal. And it's often referred to then as what we call the power zone. So schematically, you want to think about knuckle height to shoulder height, and then even notice there's a smaller target within that, right? You'll see that optimally, it would be right in here. That would mean like level with the elbows, like say for routine light type work. That's what we spoke of earlier. So, and then you should be aware too, doctors, that we most of the time think of lifting, and we think of lifting in the act of flexion. Your body is flexed, and then as you go to lift the object, we call that concentric toward the midline. But you need to know that when they do the biomechanics of it, they have come to know that eccentric loading or lowering actually requires more energy, a greater expenditure of kilocalories. So you want to think in terms of the greater demand is during the lowering activity. So when you teach workers lifting principles, don't ignore that, okay? So studies that have found that more energy and exertion or force is required during the lowering or eccentric aspect of lifting tasks than in the lifting or concentric component of it. So here we can picture the worker doing one or the other, might be in the act of lifting or the act of lowering, but certainly we need to be aware that lowering is not without its risk. You think you're working with gravity, but you're resisting the object from falling, right? And so just kind of put that into the equation. And of course, we know the importance of movement. As chiropractors, we have just a great inclination to recognize the critical nature of maintaining bodily movement by any mode or any expression. This is one of the reasons that as an educator, you'll remember, John, in classroom, I just never stand still. And I don't use a podium simply because I try to honor this principle. I got to mobilize the waste product, right? You got to get rid of the toxic buildup. So static loading results in stagnation and buildup of waste products of muscle metabolism, carbon dioxide, lactic acid, uric acid, and so on. And then that chiropractic axiom, where there's movement, there's life. And so I get a kick out of this one. And by the way, I want to give credit to our friends Steve Conway and Scott Bouch. Some of you may remember them, and I think you guys will remember them from the Diplomate program. They were gracious enough to permit my borrowing a few of these slides from them. So this is a nice program they put together for preventing carpal tunnel syndrome, but this is why they're describing it here in terms of it has the potential for affecting all of our body parts. But I thought the spider webs were kind of symbolic, kind of cute rendering of static loading. So prolonged periods, obviously many occupations require a very minimum amount of movement, but optionally, obviously people, must be encouraged to move about as much as they can. And obviously there is a lot of restraint in that because many people work at very static kinds of workstations. So now, of course, with that, part of the other part of the equation is, of course, excessive dynamic motion, right? Any physical motion that is, all physical movement is highly desirable, however, performed at a pace. And the underlying word there is pace, right? If the pace that exceeds the body's ability to adequately recover between loads, fatigue and injury can result. I think you all know back in your early days of physiology, they talked about, a classic example of this is the human heart, right? The human heart will last, some people over 100 years, even though it's, 24/7, 365. That's a muscle that never rests, seemingly, except of course it does, on a very defined rate. It rests between beats, right? But it also probably pumps away that waste material, right? See, it's that static loading is when that waste accumulates, but as long as you keep that whole rhythmic activity of the muscle pumping, facilitates getting rid of that buildup of waste product. But so management must weigh the cost-benefit ratio in determining the pace of the work operations. And of course, we picture immediately, you think of the assembly line, right? How fast is that assembly line going past the worker and the pace that they can do their job without running into this excessive dynamic overload. And again, in combination probably with reaching and other things. So when the pace of the work is critical, the physical demands imposed by excessive loads is equally important. Spinal injury is most apt to occur, of course, and you can think about that, right? What's the worst scenario? Well, an excessive load is lifted in an unprepared manner. And doctors, I think what I'm going to do, if you bear with me, I'm going to just click these back for a moment because there's a difference in one of the images, and I had the intention to use it as a point to leave with you, and then we'll come to it in a little while. When we were talking about load moment earlier, we showed you the image of one looked like a steel worker who is tying steel. Maybe you've had some awareness of what that is in a construction site, and I'll show you in a moment here. That's what this guy is probably doing. He's tying steel. These are rebar that's going to go into poured concrete, right? And you have to physically with wire, but you're constantly moving. So he's in this posture doing this probably hour after hour, rather than in a posture that would be more desirable. Is there a difference? Do you see a difference, though, in the two workers? They're both creating tremendous load moment, right? But one has a uniquely different, go ahead, say it, Dr. Green. The base of support is different, right? Could that make a difference? And does it make a difference? let me say this, you guys. How many of you have heard of power lift? Dr. Michael Schaefer's approach to lifting tasks. So many of you, have you been certified? Gary, I think you've been certified, Don. Is that not an extraordinarily important part of Dr. Schaefer's patented, system of lifting? And so to that end, just realize that, you guys, if you can coach the worker who is forced to do flexion activity on a regular basis, get them to separate their feet. And by the way, there's a boundary statement that I need to express. Bottom line to it, when you're coaching the worker, we don't say, separate your legs. Do you get it? For male or female, right? Again, it's that political, and I mean, that's kind of the buzzword, the political correctness. You separate your feet, but it's a different connotation. Do you get the idea? So just realize that you have to be sensitive about how you instruct people. And when you're dealing with a mixed work population, again, just kind of be sensitive about that. But indeed, this gentleman on the right is suffering less stress to his frame. Now, he's still not doing it the way Dr. Schaefer would recommend, because, the notion would be that you want to get your feet 12 inches wider than your shoulders. And what that does, of course, is put you much closer to the task. Also, you're working with your thigh musculature rather than your lumbar musculature. So there's a lot of principles behind it. And of course, he, holds, that this is a critical difference in manual material handling. Also, he has a course teaching for the nursing home, long-term care, hospital worker facility. That whole concept will hold great value in that as well. We're working indirectly to try to restore I don't know if you knew that, Don, and it's kind of like we're not sure where that may go, but ultimately we hope that can be more broadly disseminated, within the chiropractic community in the future. So, did somebody have a question come? Go ahead.
It's needed to tie steel, but could he be on his belly?
Well, first of all, if there's any possible way to turn this slab vertically, right? I mean, that would be where you could just do it in front of you. I mean, you get a crane, and because these are usually slabs, they're like 12 by 30 or whatever, and they've got big, and then they raise them up, and then they, whatever. It could be a floor though, and if it's a flooring, then they may not have much choice. But right, in the ergonomics equipment. In fact, I think it's shown in one of the slides that we might show tomorrow, where we go to one of the websites that NIOSH puts together, and then you'll see different applications. But right, you think of these guys that are working in a automotive garage, where they're on these little, it's a little gadget. There's a name. Yeah, the creeper. Right. Same idea, only they'd be on their belly maybe, because again, it looks ridiculous, doesn't it? But yet you can see the pace. And he's probably thinking that, well, he's saving time by not getting lower, but it's an example, right, of, it's a forced environment. He may or may not have much choice in the matter, but.
From experience in doing that within my life, is that, you can't, and you're usually either using what are called pigtails, or you're using a spindle of wire and using it to clip it.
Then you're just down there in the dirt.
You have it heavy enough, and there's also, depends on how wide the grates are.
Yeah.
Yeah.
And sometimes you're up on the third floor, right, too, and I've done that too. So, okay, so we're just going to go through these slides again, and just wanted to make that point, though, you guys, in terms of the idea of wide stance. Wide stance lifting obviously is going to be safer, more efficient, more effective, and whatever. So. So if this is the case, worst case scenario, right? Excessive load and unprepared tissues, right? That would be the worst probable type of situation. So most effective way then of preventing spinal injury is to modify the load demand and of course adequately preparing the worker for the load. That goes back into training, the whole idea of teaching proper lifting methodology. And I would just tell you this, you guys, that for the most part, it doesn't work. Back schools, the whole consciousness of thinking that you can train people to lift more effectively. Quite frankly, the only system that I've ever observed or know to be effective is power lift, quite frankly. And to that end, literally millions and millions of dollars have been spent on the part of management for what we would say mostly the Hawthorne effect. What does that mean? That, well, management tried and the workers perceived that something was being done on their behalf. But how do you tell the difference? The sustained outcome. Because see, the whole Hawthorne effect will have it'll have a benefit, but usually it's a really diminishing return. By 6 weeks, no longer. The Hawthorne effect is forgotten about, so to speak. What makes the difference? Behavioral modification. You've got to get people to want to do it differently. And that's where Dr. Schaefer's program has been so much more effective. They buy in to the difference because he shows them that it's easier and they feel the difference immediately. So I just want to share that with you. I would say be really careful about taking a off-the-shelf back school and think that you're going to have a positive outcome. Quite frankly, like I said, it's a waste of time and a waste of money and putting your reputation at risk, which you can't afford, right, you guys? You can't have another, what would we say, failure on management's part, another wasted effort, because it had no real demonstrable benefit over time. And that's a key difference. So you don't want to engage in things that aren't productive and truly known to be time-honored, like you say. These are concepts that they're pretty irrefutable. I mean, if you follow what we're sharing here, you're going to be in a position of recommending things that have been shown to be valuable over time. So, and then two-person lifts. Whenever an excessive load demand is encountered, workers must engage in a co-worker to assist in the task, and that again is somewhat of a middle management kind of thing where they have to observe when workers are going off on their own and doing stuff that should be done by two people. You got to have middle management intervention. Say, John, Bill, get them together and do a two-person lift. Some cases, up to 4 or more workers are called upon for extreme lifts where mechanical assistance is not available or where space does not permit its use. Think of for a moment what calls to mind immediately is pallbearers, right? How many? Do they have 2 people? 4 people? No, they have 6 people carrying the coffin. That's usually about the coffin itself nowadays, though, with all the fancies, are probably 100 to 200 or 300 pounds of coffin. And then, of course, the corpse. But what I'm getting at is that would be an example of a multi-person lift, even though just to observe it, it wouldn't look like that would be that demanding. But if you've served in that role, you know that it is a heavy load, and it's just an example of it. And so here's an example of, transfer of patient they're being trained to transfer patients in a care facility, so to speak. But of course, you can see what we spoke of earlier now, the idea of load moments, right? And in terms of the feet are close together here. I see what I'm getting at? This would be an example of the traditional lifting sort of physical therapists, if you will, occupational therapists, chiros as well, people who do, if you will, the off-the-shelf kind of training. They're not conscious of the importance of wide stance lifting. Even though it's a 2-person lift, they're still putting themselves at notable risk because there's still significant load moment potential here. So whenever possible, obviously 2 persons is one option. And then, of course, to utilize mechanical assistance when and wherever possible. Very critical. Certainly the less expensive and readily available, the simple truck in a work environment, compared to a more sophisticated one where, it's mechanized, it's motorized, it's, got a lot of, neat advantages. One thing about large objects such as barrels, one of the principles that we talk about in our training is instead of lifting that barrel, we would recommend we use the term walk at home. You can literally, without lifting almost at all, you can roll it on its edge, and we use the term walk at home. And you could do that with a round, or you could do it with a vertical, large, heavy object, that's got like 4 corners, like a big box that's too heavy to transfer. You can literally, you can walk at home. This is a concept that we think is a relevant one. And of course, to utilize this kind of equipment, but as we said, this comes with some costs, right? And again, it would be an engineering control, right? It's an intervention that is utilizing the best of available mechanical assistant systems. Of course, to prepare the worker, as we said before, one of the options, reduce the load would be one way, or use mechanical lifts or another worker, co-worker. But also, we can engage in conditioning or strengthening activities. Structural spinal alignment, you think it could be important to reduce the existent load moments in the spine, right? Keep that in mind, what we spoke of earlier, the buckling point, the subluxed segments in the spine. If they're not addressed, they still remain very vulnerable to collapse, right? The whole idea of buckling. And then stretching programs. Interestingly, there's some controversy as to the effectiveness, the cost-benefit ratio of stretching programs, just for your awareness. It isn't like universally agreed that it's necessarily, shall we say, an intervention that enjoys high levels of documented evidence of effectiveness. Let me qualify. I'm thinking that's true if it's the only thing you do. I'm saying, though, use it, but do it in combination with other things, right? I don't think there could be ever a harm, and in fact, I'm convinced that there's benefit. But I suspect what they were measuring is that if that's the only program that was being measured, that now you incorporated a stretching program and then you monitor the outcomes. I'm saying, well, I wouldn't do that. I would do a whole bunch of things, right? That's my point. I wouldn't want to depend on it, though, as being. And let me just say about back schools again, I think back schools could be valuable for again, I wouldn't diminish the Hawthorne effect, right? I'm going to say go ahead and do them, especially if you know something about it, but then don't put all of your eggs in one basket. And that's why we as chiropractors, we always recommend don't go in as a la carte. A company calls you and say, well, doc, would you be willing to come in and teach our workers how to lift and all our problems are going to go away? And of course, a lot of chiropractors jump at the opportunity and they think, oh my, I've got my foot in the door and this is a wonderful thing. And wait a minute, folks. First of all, how do we know it's going to help that company? How do we know that's even what they really need? Same thing with the stretching program or anything else that you do, right? We're going to say go in and think in terms of, think like a physician rather than a technician. Does that make sense? You think about it in the way a doctor analyzes a patient's needs. There's a lot of parallel to this, by the way. When we do our needs assessment, we follow a very methodical process. And the very, very first thing we do is a very careful needs assessment. And that's equivalent to a very careful history, right? Like you're doing a history on the patient, same thing, we're doing a history of the company's issues, right? The who, the what, the when, the where, the how, and what shift, and what male or female or whatever, how long have they worked, and which workstations and whatever. You want to get exquisitely detailed information about where the problems reside, because how can you effectively address the problems? So if you go in with a solution that has no basis in fact, we discourage that, folks. Why? Because your reputation is on the line. And again, it's usually not going to prove very beneficial because you're not addressing the total picture. So think holistically, right? To include, as we said, the consciousness of holism, that means body, mind, and spirit. That means attitudes, right? Patients and workers' attitude, right? As we do with our patients. All of this is part of the basic core chiropractic philosophy, which you guys can so relate to. And then, as we said, training proper lifting techniques, but, as we said, proper is the sort of the deciding word there. And this is one of the things that's been missing in most of the so-called back schools as well. The idea of, hey, it's there's an axiom that says, your spine is not any healthier than you are. Right? I mean, how could your spine be any healthier than you are? And so if you don't take care of your health, how can you take care of, get the idea? And of course, because the spine is so related to your nervous system's ability to maintain homeostasis, it works the other way too, right? If you want to have good health, take care of your spine. But if you want to have a good spine, you got to take care of your health, and that means you got to be properly nourished. And you got to have, all of the elements having to do with hydration and, realization of, nicotine is very destructive to vitamin C, and vitamin C is critical for collagen repair. And, you're talking about smokers compared to non-smokers, and you talk about all of those factors, right? So that's why we're saying, you guys, in terms of preparing the worker, you can have the most ergonomically, scientifically sophisticated work environment, but if you don't have a healthy worker in that environment, that's why we put the emphasis on, doing pre-placement physical screening exams would be another, major contributing factor to a successful outcome. Go ahead, Ron.
The industry looked at that in relation to what the Oriental businesses are doing with their, the whole workforce is doing their
exercise and warm-ups and, right.
And obviously it's not just stretching, but it's team building, and
Right.
the CEOs are out there and the workers are out there, and
Yeah.
it's not just stretching. So
The other fun thing about that is it's part of their culture, and it's often done to music, and it's often incorporating some of these unique Tai Chi and, Qigong and some of these other, again, ancient principles that have a means of helping to bring stabilization within the nervous system and a calming effect, or, whatever its objectives can be achieved through. And again, when we were in China, literally, we in the morning, literally, it was common out in the parks, you'd see like 200 people, and often they were in a very rhythmic dancing routine, and it was like old, middle-aged, women, children, whatever. It's part of their culture. And again, we think there's some significant value. I think is it Japan that still enjoys the greatest longevity of any country? I'm pretty sure it's Japan, if I'm not mistaken, but it would be an example of.
we're kind of stuck in this Midwest mentality. Is that being done anywhere in the United States? Does anyone have any idea of that, if that model has even made a splash?
Well, I think the closest thing might be like stretching programs, right? Let me say this about stretching programs, you guys. If you want to be scientific about it and yet very practical, and its relevance is just so logical, if you can figure out which muscles are being contracted, what does contraction of muscle do? Shorten the muscle, right? So if you see the worker and realize which muscles that they're shortening all the time, they're the muscles that need to be stretched, okay? And don't complicate it, right? Just think of it as how simple is that, right? So if you're constantly in a mode where you're contracting certain muscle patterns, muscle pairs, well, those are the ones that you would, and again, it's tailored then, isn't it? It's not like one size fits all, where 50 people all in one, sort of just because they're employed at the same facility doesn't mean that those same muscles are. So that's another way that you can tailor it to their individual needs. So that's my own personal point of view on it, and pretty straightforward. But this is why, as we said, in the worker selection process, the physical exam that we teach in our diplomate program basically is a full body exam from eye, ear, nose, throat to all bodily functions and hernia checks and cardiovascular, all of those things. But its focus is on preventing lower spinal injury, and so that's where the biomechanical stress index comes from. And in my own experience with that, you guys, probably it'll come up a little bit later, but that's really where I kind of cut my teeth in the world of occupational health. Jim Martineau was a president of a glass fabrication company in our community. And he called one evening and he said, Joe, would you be interested in helping us prevent lower back injuries? I'd just been appointed by the governor to serve as a chiropractic representative for the Department of Labor. And Mr. Martineau had seen that in the paper, and so he called and he said, well, you must have a greater interest than most docs in town. Would you be interested? So I went and met with them around the table, and they said they were getting a lot of pressure, if you will, from Liberty Mutual, their work comp insurance carrier, because they were considered an outlier. In the insurance world, as you know, they are permitted to charge premiums based on losses, right? But they're limited in how much they can charge, right? And it's based on the category of work. And so in this case, their insurance premium was based on other glass fabrication companies, right? But they were considered an outlier, but they're still limited by the insurance industry how much premium they could charge. So they were not profitable in this particular company. So the insurance company said, we've got to get your spine injury problem under control. 56% of their low back injuries were occurring within the first 6 months of hire. And even though they were conditioning their workers, they were training their workers, they were incorporating all of the ergonomic interventions that were at their disposal back at their time. So Liberty Mutual says, you're doing everything that we know to be valuable, but what you're not doing is screening your workers. You're putting, a high-risk worker into a high-risk work occupation. What you want to do is, that's a bad scenario. That's an accident waiting to happen. If you can either diminish the risk of the work, reduce that, or you've got to figure out who's more appropriate to do that kind of work. So we began a program that we eventually spoke of, or it's now referred to as the Biomechanical Stress Index. And I'll just share a little bit of the outcome of that, because it kind of put the basic chiropractic theory to the task, so to speak. And the theory was that there is a direct relationship between human form and human function, human structure and human function, so to speak. So I reasoned that the more biomechanically, structurally compromised a person would be, the more likely they would be to suffer spine injury. So we began the assessment process, and at the end of the third year, I got a call from Mr. Martineau. He asked me if I wanted to go to lunch. And so sitting across from the table at Perkins, he pulled out an envelope from his pocket. He said, I want to show you this. And he said, Joe, I want you to know that you're responsible. So I looked inside the envelope, and inside it was a check for $600,000 of unused work on premium. What Don mentioned earlier, that served as his project for his diplomate program, doing employment physicals. Well, in this case, they were doing a lot of hiring. I think we did like 600 physicals for them over the years. But at the end of the third year already, they had saved, or they got a rebate, if you will, of unused work on premium from Liberty Mutual. To give you an idea of how effective a chiropractically oriented physical exam, turned out to be. And so, even though some of my cronies in the profession would say this as well, that's a fluke, you never be able to replicate that. At that point, Mr. Martineau, by the way, said, we want you to raise your fee. I mean, he was just expressing his gratitude for it. But at that point, it came to me that, there's one area in this profession that we're not addressing, and that is the whole idea there's a lot of unnecessary human suffering out there. And so we approached the school here with the notion of creating a program for postgraduate training in occupational health. And so in 1983, we graduated our first group of docs in the program. And one of those doctors is Dr. Michael Suppy, who's a chiropractor practicing in Carroll, Iowa. And Dr. Suppy happened to be on campus a couple of years ago when I was training a group of docs just like you guys. And this doc walked in the room, and it was probably 40 minutes into the program, and he was going to come in, and I said, hey, you should sign in, because get credit hours for your license renewal. And he said, no, he said, Joe, I just noticed that you were teaching this program this weekend, and he said, I happen to be on campus, so I came by to say hello, but he said, I came by to say thank you. He said, right now I've got 15 companies that send all of their workers to us for the BSI physical. I said, gosh, Mike, that's kind of impressive. How many exams do you think that you've done? And he said, well, I don't know, but we'll get back to you on that. And so about a week later, he called and he said, as far as we can figure, we've done about 20,000 of these physical exams for these companies. And I said, well, and they come from as far as 50 miles away. And I said, well, that's kind of intriguing because, as you guys know in science, the first challenge in any kind of a diagnostic or assessment system is that it has to be reliable. What does that mean? That Dr. A and Dr. B and Dr. C, given the same data, given the same person they're assessing, they should be able to agree on what they observe, right? And then they ought to be able to come up with what we would consider the same outcome. So that was the key question. I asked Dr. Suppi, well, what % of the workers in your community, Carroll, Iowa, compared to Owatonna, Minnesota? Well, geographically, that's not that far apart, but, and I said, different age groups and whatever. He says, well, you taught us that it would vary depending on the job description, right? It's not an absolute thing, but ultimately, he said, we've done checking, and based on the different companies and the different job descriptions, the ratio of people who pass the physical compared to those who are found to be at an unacceptable risk category, he said it's between 12 and 16%. And I said, well, that's pretty cool, because in our Viricon project, it was at exactly 15%. So that said something rather dramatically, that not only could the system be taught to others, that they could replicate it and they could achieve the same outcome. Because in science, as you know, that's critical. The question of reliability is the first thing. The second thing, though, is called validity. Does it do what it purports to do, right? Is it, in fact, valid based on the fact that it's supposed to be predictive, right? You can predict who's going to suffer spine injuries. So I shared that with you as well as another tool. It's another service. It's another item on your menu, just like drug testing and DOT physical exams. Well, you can certainly be trained and take that weekend training of the DOT, and you'll be capable of offering that to the corporate community as well. Because that's what's going to happen, you guys. Once you start doing one service, in this case, you'll have some understanding of ergonomic interventions, right? And next week we'll talk about what Chad does on site, how he actually makes it work, and all the do's and don'ts, do's and don'ts and whatever. And then, of course, there are medical legal aspects, when you're dealing with the work comp arena. So that's the 3-session program that we are providing for you. But I share with you that there's a broad menu of things that you can do as a chiropractor to facilitate an improvement in workplace health, wellness, and safety. Go ahead, Chris.
Just a story of, I was talking to Montevideo, as Brett said, we have a lot of industry and a lot of construction in our town. And I was approaching some companies about doing DOT, or not DOT, but drug testing, pre-employment physicals. And one of the concerns that the person who did the hiring said is that if we start doing those, we're going to eliminate a lot of people from being hired, and there aren't enough people around here to.
Yeah.
So he said, I don't want to do drug testings and things because I'm not going to have enough people to do my job.
Yeah. That's one.
A bad reverse way of thinking, but
Yeah.
that's the way it is in rural communities where there aren't enough workers.
It is so true, and this is what we touched on earlier, attracting desirable workers and retaining them, maintaining them, as keeping them happy, right? And then you're exactly right. I think rural communities especially are struggling with that very issue, to attract, and retain good workers over time. Of course, they might be able to change that if they could pay them better, like think about entry-level nursing home, right? These young people who, it's their very first job. But I think that's one category of workers that, oh my goodness, talk about an underpaid work population. No wonder. Do you know what the worker turnover rate in the average nursing home in this country is? 100% per year. That means every quarter, 1/4 of your workplace is new. And then just think of the training costs. Think of, oh my goodness sake. So that's an example of it, right? And of course, what could remedy that? Well, if they paid those workers a decent wage and then gave them, the respect and all of the things that could make their workplace a more desirable facility. Anyway, I wanted to share these concepts briefly with you to help you to know we're sharing sort of a menu, right, of various things you might consider doing, but we also offer you the opportunity to gain more menu in the comfort of your own home by just doing the DVD weekend, doing it online, if you will, and it's available to you. So anyway, we'll continue. Sometimes clothing is an issue, as you might expect, you guys. Bulk is an issue. Garments may become accidentally caught in machinery and so on. Just be conscious of this. Not that it's a huge concern, but it can be, especially around moving, machinery with gears and belts and various things. But then, of course, in colder climates, can be also an issue, right? The bulk of making things difficult in terms of efficiency and dexterity and whatever. Next consideration is what is referred to as a barrier. Barriers in the workplace. We suggest, therefore, to eliminate, to the degree possible, eliminate barriers that prevent optimal posture and require excessive forward reaching. That would mean if the work that I'm expected to do is over there, I can't get close enough to be efficient, right? I'm forcing my body, into a load moment, a flexion, undesirable situation, right? So your job as a consultant is to try to eliminate this barrier. Let the worker get close enough, if it's an assembly or some kind of a conveyor or whatever it may be. Pardon me? Shelving would be, sure, lots of examples of that. Now, when we talk about this, though, this would be an example of a classic barrier. However, there is a consideration of using something like this as what we call a lean bar. And I'll talk about that a little bit later, but just realize this for now, you guys, that barriers can indeed be a significant issue. The workers need to be able to stand or sit close enough to the objects that they're working on or transferring so they can keep the activity close to their body. Remember the power zone, folks? The idea not to exceed fingertip reach, that's the ideal, right? Anytime you're exceeding that, you're creating a load moment. So poorly designed conveyors or assembly lines may be examples. Then you have this scenario where you can see like the before and the after. You can see that this is kind of like a cage where supplies or portions, components of the whatever they're doing are provided to them in a cage-like apparatus. Might even have wheels on. It's brought to the area. And then, of course, by the time you get to the bottom, maybe it came out and it was full. Right? It had widgets in it, and they were components that were going to be applied to whatever they were manufacturing. Well, by the time you get to the bottom of it, you've got this incredibly stressful situation, and of course you can't get close enough to it as well. So then to remedy it, you can see what's done here. Maybe what we could do is minimize some of the glare on the screen. You might be able to see a little bit better. You can see that they've tilted this mechanism such that now the worker at least can access them far more. It's maybe still not optimal, may not be optimal, but it's a great improvement. So just to have you reflect on the possibility of that. Here we talk about the idea of lean bar. Sometimes if a physical barrier happens to be of an appropriate height from the floor, it can actually be used as a lean bar and reduce the strain on the body when performing tasks. And so the optimal position of the lean bar would have to be, though, just below the anterior superior iliac spines, and then with physical contact on the upper thigh, so that in some measure then you're using it to lean on. So now you have minimized the load moment. Your feet are back here. My lumbar spine is not flexed, right? Obviously this is still too low. It should be higher, but if this were a situation where sometimes the barrier could actually facilitate another, like making a tripod. So just kind of think of it in that way. By the way, who are really vulnerable to this scenario? If you want to think about this for a moment, put yourself in the shoes of surgeons doing 3, 4, 5, 6 hour surgeries. Think of doing scoliosis surgeries, averaging 6 hours. Bent in that incredible posture. Did you know that there is an apparatus that they actually have designed to, it anchors to the surgical table, and then it's a chest plate. And it literally lets the surgeon lean into this chest plate that's mounted here. In some measure, it would be fulfilling the same objective. Does that make some sense? But of course, surgeons are only one of a wide variety of occupations where this might be a scenario that you'd have to be thinking about. Housekeeping, well, obviously, as we said, slips and trips and falls account for 23% of time loss work-related injuries, most occurring, interestingly enough, on level surfaces rather than from heights such as ladders or scaffolding. Many result in fractures and dislocations, right? Because they're usually like a slippery environment, right? Like we say, wet and slippery floors. By the way, in restaurants, this is an extraordinarily high incident. Cuts from cutting salads, right? You know, restaurants have high incidence of cuts. They have high incidence of slips and falls. So, and you can see the logic. It's their exposure factor. So, of course, the wet surface is of concern there, and not only wet. You know, you got salad dressings, which would be oil, right? You got grease. You got all of these cooking oils, baking oils. You got all those elements to consider. So, no surprise there. And then, though, of course, basic housekeeping, junk that's laying around on the floors is, you know, and then, of course, many times it's where the worker, their vision is obscured so that they literally trip over objects. And sometimes it's an electrical cord or, you know, whatever. It's something that is just like core simplicity in terms of housekeeping. But what did we say earlier about that? Zero tolerance, right? Middle management, you got to intervene. And of course, the discipline has to be harsh. It has to be immediate. It's kind of like cutting tools. There has to be discipline regarding the use of gloves. Anybody that's engaged in cutting activities on a regular basis, anytime they have a cutting tool, if they don't have their gloves on, that's a pink slip. You get 2 warnings, folks. You don't have to work here, but you do have to pay attention to the rules. That's what we mean by zero tolerance, right? That's called tough love, right? Because we'd prefer that you keep your fingers, right? And prefer that you obviously want to work here in a happy work environment. This is what we talked about earlier in terms of middle management having to deal with that. And unless you're kind of cut out for it, it's kind of like your children never growing up, right? I mean, when you talk to a 4-year-old, that's one thing. But when they're 14, what if they never grew out of their teenage years? Those of you who have been parents into the teenage world, consider that, right? And the workforce is like that. You're dealing with, you know, children who aren't catching on to their basic rules. And of course, it's for their own benefit. And this is what we meant earlier about tough love. I'm going to digress just a little bit here because you'd say, well, what would the chiropractor's interest in hearing loss? Well, every effort must be made to preserve vital functions of the body, such as we spoke of earlier in the early days of OSHA. Remember, life, limb, and then bodily functions. Vision and hearing were on that list, very critical. Hearing loss is a common work-related disorder secondary to excessive noise. Also, I'm not sure if you are aware, but a hearing loss is considered, total hearing loss, total deafness, is of greater handicap to humans than total blindness. And that's pretty startling to think about in terms of how casual we are with regard to the threats to our hearing and then amount of noise we allow ourselves, especially kids nowadays, with, you know, with their headsets and all the racket, all the musical. Well, you know, keep that in mind. In my era, it was the military. I mean, that was, you know, you're out on the rifle range or you're shooting machine guns and there's no control. We had never had any hearing protection. And I'm convinced I lost part of my hearing as early. My brother was in the Navy and he was working in in the undercarriage of a huge transport ship and dealing with diesel engines. A lot of agricultural workers too have serious hearing loss from diesel motors. It's that hertz, it's that frequency that are very destructive. So we need to be sensitive, conscious of this as a very serious handicapping phenomenon. So an administrative control is, of course, extreme zero tolerance rule for failure to use proper ear protection, as I mentioned earlier. Half of that bay of workers is using their earplugs, the other half not. And as we said, compliance is an issue. And of course, there's some reason for it, as we said. It's difficult to communicate when you can't hear your coworkers. And so it's part of that issue. And I said digression for a moment because right now we're going to be looking at this issue from another perspective. Workers exposed to excessive noise conditions are expected to wear earplugs in all areas where the sounds exceed, and this may be new terminology for you guys. Have you heard of MPLs? That's a language, I'm in a little, it's the only time I'm mentioning it this whole weekend. However, for the ergonomists, it's their bread and butter, right, Chad? It's kind of like that's what they have to be ever conscious of. And of course, that's what OSHA is really all about. That's what NIOSH is all about, maximum permissible limits. Kind of touched on it a little bit when we said, well, what's the amount of maximum permissible, mercury and, in fish before it's thought to be palatable, whatever. Bottom line to it is similarly, workers' exposure to noxious sound, there is a limit that is permissible under the law, under the OSHA regs. So we call that maximal permissible limits. It's common for workers to be casual about this requirement, and certainly, as we said, from the standpoint of using earplugs, any of you have had experience with that, they're never fun. I mean, they're irritating, quite frankly, after a while. You can easily get irritation to the point of infection, right? Because they chafe and they irritate and whatever. So compliance becomes an issue. And as we said, communication between workers is another reason. So an engineering control might be, well, where is the source of all that racket, and could we contain it somehow? Noise abatement, and or other means by which you can reduce the actual amount of racket that people are exposed to is a critical concern. Sometimes it's really subtle, folks. Not so much anymore because it's an improved technology, but you remember the times when you'd walk into a hardware store or anywhere, and even in a regular work environment, but let's say in a retail outlet, and they didn't pay attention to the fluorescent lamps and the gadgets we're wearing out. So you heard that constant sound of fluorescent bulbs that were starting to wear out, and this would be really subtle, and the workers became oblivious to it. Right? You're not even conscious of it anymore, but it's still there. It's still an irritating factor. In fact, right now, listen carefully, folks. Do you hear that sound? If that weren't there, I wouldn't have to speak as loudly. And it may be, do you think it's the air conditioning? It might be something, I'm not sure where it is. But nonetheless, there is a sound in this room that we've been, until I brought it to your awareness, right? You didn't pay any attention to it. And that's true for the average worker as well. But you coming in and observing it, to you it's an immediate sort of irritation, right? And you would say, well, my goodness sakes, how could the workers not be aware, and wouldn't they be complaining? And wouldn't this in fact be a major issue for everyone in that environment? What's less of a concern, I'll say the example of the fluorescent light. But of course there's other sources of sound that we don't, and of course you multiply that by many, many expressions of sound. Many, many workplaces are extremely racket driven. I mean, from grinding to sawing and pounding and all kinds of activities. Again, once you've been around that environment and you realize what kind of exposure, and I'm sure most workers really take it quite for granted because they're so used to it, they get conditioned to it. But of course, you know, the cilia in the ear doesn't get used to it. It just wears, right? And so that's a real issue. So what this suggests, you guys, this usually involves expertise that may be outside the scope of the typical chiropractor or the training that we provide. In such instances, the most appropriate scenario would be where you would outsource this kind of service. And so now it brings us to our opportunity to touch base on who these people might be. And I mentioned a little while ago the industrial ergonomist, the industrial hygienist might be the individual that you would call upon to work on a challenge such as a high noise exposure situation. For many such technical challenges, the occupational health specialist most qualified to perform such services is the industrial hygienist. This professional usually possesses, again, a master's degree or PhD in occupational and environmental medicine. And they're certified through the American Board of Industrial Hygiene. Now keep this in mind, you guys, that while this might seem to be a very in-demand occupation, I would just tell you that it's pretty unusual that an employer would engage a full-time industrial hygienist unless they're a major Fortune 500. You know, like probably General Motors has a whole bunch of them on staff, right? But the bottom line is that in you know, the regular traditional workstation is something that is outsourced, and they don't expect to work full-time. So they serve in large measure as an independent contractor, which is, by the way, Dr. Henriksen and I will be talking a little bit more about this in terms of, you know, the business aspect of serving to provide on-site chiropractic care. More than likely, you will be engaged as an independent contractor, where you would be, you know, paying your own malpractice insurance and your own benefits and, you know, all of those things. Similarly, that would be true for these kind of folks. I think most ergonomists, unless you're dealing with a really large company, most ergonomists, again, work as an independent contractor and called upon as needed, so to speak. And they might be called upon when a manufacturer, let's say, is you know, deciding that they need to engage in the creation of a whole new wing or a whole new process, and then they may say, well, we really should bring on an ergonomist to facilitate that. Or, of course, when they're running into where they're hemorrhaging, right, where they're in a really serious situation, you know, because a lot of times, unless they're bleeding, folks, they won't say, well, we don't need these people yet. You have to wait till there's a crisis, and so kind of put that in perspective. Now, the hygienist would be able to measure with technology, measure in decibels the high exposure locations within the work environment, and then determine then whether or not it exceeds this maximum permissible limit again, whether or not they are already in a potential OSHA violation situation, and advise the employer regarding the most appropriate intervention strategies, including, obviously, noise abatement techniques. And of course, there's a lot of means by which you can minimize the amount of sound that's taking place, although it is limited again as well. So just realize that. While they're there, when noise abatement has been accomplished to the best degree possible, and the middle management has obtained a good level of worker compliance regarding the workers' exposure through use of like ear protection. There may still be other factors, you guys, and this is what I wanted to leave you with to think about. As an example, a cleaning solvent known as toluene that's been linked or has been linked to hearing loss. And how I know this, what caused me to be aware of it is a couple of years ago, I was called upon to do an assessment for a fairly large, well, a medium size, it happened to be a printing facility. And they had like 400 some employees. And what was so intriguing is that we asked for the data. Like we said, we want to do our assessment based on hard data. We want to get precision information with regard to knowing what their needs are. So we asked for data going back 3 years in terms of the incident and severity and work, absenteeism and all of the various factors. So part of that data resulted in the fact that we learned that in the past 3 years, they had 7 workers that had filed work comp claims for hearing loss. And that was tremendously outside of the norm, right? I mean, they had 3 work comp claims for hearing loss in a facility of 400 employees. And that would be pretty much extraordinarily unusual. So it immediately caused me to step out of my comfort zone and said, look, folks, I think you better be looking at some environmental, toxic element in your workplace, your work environment. And so the first thing that came to my mind was looking at toluene as a chemical exposure factor, and sure enough, they were using this as a solvent. And so it was another way, even though, and it was because of my training though, my broad, let's say, exposure to occupational health awareness that caused me to be aware as well. You should be aware as well that while your comfort zone is going to be a neuromusculoskeletal specialist, right? Just realize in the bigger picture, especially in these smaller employers who doesn't, probably have the capacity or the willingness to engage in, say, an industrial hygienist or a professional ergonomist or whether that your role can go beyond the things that we're talking about this weekend, okay? So in that regard, I'm digressing, but I'm doing it for 2 reasons: to help you to know that you don't have to be everything, right? See, the DC should not feel concerned about the fact that, you're not, expected to know everything or to be an expert in everything that. So engaging, obviously, in, relationship building, we recommend strongly that you have, just like you do in your clinical practice, you have clinicians outside of your own discipline, right, that you refer to, that, you work with radiologists on a regular basis, but you probably also have a fairly, may not be a long list of orthopedic surgeons and neurologists and others. Similarly, with this work, folks, you would know that when something is required that's outside of your, highest level of expertise. And so we urge you to be thinking about that. The DC should not feel that they should be things to all things to all people. And surely occupational health is a team sport. And to that end, you would, have no reason to feel. I mean, you don't feel teeth, right? You don't, you don't remove tonsils, but you don't feel bad about that. You get the idea? That's what we're saying. The world is moving really rapidly toward the realm of what we call integration. So, thank you for your attention, doctors. How fortunate we are as a society to have access to all of the innovation that has changed the physical demands to the human workplace. Keeping in mind, of course, that common sense would suggest that if there's a choice of doing it by hand or doing it with mechanical or machinery, this would be. And of course, the issue still comes back to cost factors and return on investment and whatever. So I would just like to, help us to understand that there's a great deal of, shall we say, importance to, let's say, back up for a moment. I just want to leave this with you to think about for a moment. You'll notice that this is a Model A. Well, a Model A suggests that there might be a Model B, right? And so you want to kind of think about that in terms of, and again, it kind of picks up a little bit on the biomechanical stress index. The reason that we would remind you of this, you guys. If there's a Model A, it might have a limited capacity in its efficient work capability. In other words, Models A are designed to have lifting loads not to exceed maybe 400 pounds. But maybe a Model B would have the capacity to lift up to 800 pounds, and maybe a C would be able to lift up to a ton, 2,000 pounds, right? So the point is that what is the, is this guy, the machine in the red t-shirt, is that a Model A or a Model B or a Model C, right? Is it assumed that they're all Models D or whatever, capable of the maximum amount of lifting? So again, this gives you an opportunity to have management kind of think about that. They purchase equipment and machinery proportionate to the demand, the expectation, and its limitation, right? And of course, you can get a machine like this that would lift 2,000 pounds, but it may not be reasonable or logical because it costs 3 times as much as one that would lift 400 pounds, right? So again, the notion of investment, well, you have to think of workers and the machinery, right, the biomechanics of a human machine, and put it in that perspective. So I wanted to leave that with you, taking the opportunity to use that as an example to kind of reflect on that. And during the break, Dr. Henriksen reminded me of something that we were talking about hearing loss. And Chad, if you wouldn't mind just expanding on a little bit what you shared with me, because I think it's relevant and important for us to, give us the opportunity to think on that a little bit more.
Yeah, just something that everybody should be aware of is the fact that there are OSHA requirements that companies do sound testing and then provide hearing baseline testing for their employees that are subjected to sound beyond that maximum permissible limit. And so you'll oftentimes see, if you take a look at their OSHA 300 logs, that they've had recordable injuries for hearing loss, and how that's determined is against that baseline. So just be aware that companies who do have areas where the sound is more than maximum allowed will have to do a baseline testing and then annual testing of all employees within that area. And if the hearing loss, and I think I'm close with this, I think it's 3 or 4%, but if they have more than a 3 or 4% reduction in their hearing from the baseline or the previous year, it becomes a recordable injury for companies. And so it's not only advantageous for the employees to not lose their hearing and wear hearing protection, but it can become a serious violation for the companies that can economically affect the companies if they don't do it. And they're subjected they're being mandated to do this baseline testing. So companies out there will be doing it. Oftentimes it's through their risk management groups or those types of things. They'll have them come in and all employees will be tested in a day, and then a year later they'll all be tested again. But just make sure that you're aware that does take place out there.
That brings an opportunity to touch on another point. See, the application of OSHA regulations is not universal. And we'll talk a little bit about, well, obviously more during our third session, but Chad, is it not true that cutoff is employers of more than 11 employees? If they have fewer than 11 employees, which you might think of, well, that's just a mom and pop little shop, but they're human beings too, right? But they really aren't regulated by OSHA, at least certainly not across the board. So, and again, just exactly where that resides, but just to think about that as well.
And you should also be aware that government.
Right. There's a number of occupational groups, like the military, for example, the airlines, the railroad industry, agriculture, farming. None of those are regulated by OSHA. So, you want to think about that. Now, keep in mind that it's a consumer protection kind of, legislation. But if, say, we say, well, what about railroad workers? Well, as long as an industry can meet or exceed, shall we say, the same standard, well, then they will be regulated through themselves. They self-regulate, so to speak. And of course, they're under, they fall under an obligatory role to do that as well, but it isn't under the traditional OSHA mandate. So just kind of think about that. And there may be other industries as well, but all told, I believe there's, I think I'm trying to remember the number of people that are covered, if you will, as an insurance sort of, or assurance of workplace wellness and safety. I mean, you think about that as for the consumer, it's protection to the worker, that they have this coverage, if you will, that they are protected. And it's really a huge number, even when you exclude those industries that we just mentioned. I'm just not sure exactly the number right now, but it's a very, very impressive number, so to speak. Now, keep this in mind as well. Here you see a combination, right? So even though powering with motors instead of muscles, often humans are an integral component of the machine's operation and remain at notable risk. And so, usually the most efficient environment is to combine the best of both. But obviously in terms of physical, demands and stress, frequently it's a situation where machines are limited. Machines can only do a component or a certain amount of it in many environments. So. Now, if you're an agronomist and you have a challenge of reducing workplace injury, what would be your ultimate goal? Your ultimate goal would be to what? Remove the humans from the exposure, right? I mean, just don't even have humans involved. This is kind of what we touched on before when we said, well, robots might be the next. So the optimal goal of an ergonomic design is to remove humans from the work task, or at least minimize the number of workers placed in harm's way. That's another word, kind of buzzword. Employers by law are precluded from allowing workers to be exposed to what would be referred to as harm. In other words, in terms of the mandate, if an employer knowingly permits or in fact requests or requires work that puts workers in harm's way, that's not acceptable. They're vulnerable to violating OSHA regulations. So, and of course, as you can imagine, there are many, many dangerous occupations, right? And of course, sometimes there's very little, that you can do to minimize that risk. So kind of put that in perspective. So that's why, to whatever extent possible, mechanization is often the means by which this can be accomplished. Many options are available, of course. Example would be, how would we eliminate the worker or the worker's exposure, is to increase the size of the object and the materials to be handled or transferred, say from an 80-pound box or bags to containers that are 800 pounds. Why? So that then you have to bring in a forklift or some other mechanized system so that the worker doesn't have to bear that load at all, right? Now, of course, there's trade-offs, right? While this, obviously it's not always feasible, while this concept seems logical, it's not always practical for the variety of reasons, including cost, but more commonly, space considerations, such as a machine that's too large or too bulky may not be able to efficiently or safely access the required work area. Say if you have situations where this is the space between various workstations, there's no way you can get a forklift in there. I mean, as much as it would be a great idea, these surfaces are mounted and they're anchored onto the cement floor, and so that would be an idea. Well, it'd be great if we could get a machine in there to do it, but it's not possible, so space is an issue. And of course, other things like scaffolding, right? I mean, obviously, it's not reasonable to anticipate that you can get a machine to be able to do a lot of those things. So now in the category of manual material handling, which is an extraordinarily brief or broad category of work demand, what we'd like to do, and maybe this is an opportunity, might need a little assistance with this if you would be willing Andrew to give me a hand. What I'd like to do, and maybe for the remaining time today, is go online. Maybe we'll have some extra time, but there's a lot of available information, and I don't want to disrupt this. If you wouldn't mind, Andrew, what we're going to do is just go online for a minute, tap into the NIOSH. We're going to look at the ergonomic guidelines for manual material handling. And so we're going to punch in NIOSH, and we're going to go to the web, and then just use those keywords, NIOSH, ergonomic interventions for manual material handling. And then we'll see what comes up, and I think you'll see already here. And it seems to me that when I've done this, there's some really cool examples of it. And so you can look at, let's see, we're seeing video. Okay, so for example, you could tap into some examples of it. Sample exposure, so let's take a look at that just to see what comes up. NIOSH, as you can see, stands for the National Institute of Occupational Safety and Health. And he's bringing us now to the full screen, so that takes best advantage of the imagery.
Use samplers to measure workplace exposures. You might sample throughout your work shift or while you're doing one task to measure workplace exposures. You might sample throughout your work shift or while you're doing one task. We use samplers for measuring chemicals and other substances in the air. The air quality sampler has 3 parts. The pump is a box-like device usually worn along the belt line or in a special vest. It weighs about the same as a quart of milk, but it is smaller and not as bulky. The train is a plastic tube connecting the pump to the cassette. The cassette holds the filter. We put the filter near your mouth, or as we call it, your breathing zone. The filter captures substances in the air that you are breathing. We also use samplers for measuring noise. The noise sampler works like the air sampler. Instead of drawing air through a filter, it uses a microphone to measure sound. Don't worry, it does not record words or other sounds, just how loud they are. We can put samplers on people doing lots of different activities, some loud and some quiet. Some active and some calm. The samplers are lightweight and easy to manage. The tube runs along your back so it doesn't get in the way, and you may hear the soft sound of the pump drawing in air. Now that you know how we measure workplace exposures, you can see that we can do our work without interfering with yours. All you have to do is wear a sampler while you do your usual work. We will send the results from your individual sampler to you at the address that you provide. The data we collect from these samplers could help make your workplace safer. Let us know if you still have questions. And thank you for helping us out by wearing a sampler.
And then continue. We can look at a variety of these. Let's see. This one has to do with general, looks like a wellness kind of video.
Imagine the power of having torn down the walls that separate the traditional silos between
Have I been in your way?
and fitness
Are you
programs
sure?
and wellness programs,
I hope you tell me.
nutrition and HR and benefits programs. If all of them can work together, if we can avoid duplication of services, if we can look at each and every activity that each does through the lens of what's best for the overall health of the worker, at work and away from work, I think we can have a better investment of resources. Practically, this looks like fairly complex, but there are a few early simple steps that almost every employer can take. For instance, having your safety committee and your health promotion committee meet together on a regular basis. Having the leadership of both talk about their plans for the year and coordinate them to the extent possible.
taking every safety meeting or health promotion meeting and dedicating a portion of that experience to the opposite side. So imagine an all-hands meeting that's held on a regular basis that talks about safety issues. Tack on some health promotion information at the same time, and vice versa. If you have typically educational materials around health promotion, fold in ways to keep people healthy at work. And then the last thing I would say is organizational change is powerful in achieving both the health protection and health promotion aims. So think big picture. Talk about the policies that your organization needs. Talk about ways that you can change the physical environment, the culture of the workplace, the built environment. These are all powerful ways to integrate health protection and health promotion.
Andrew, there is one on manual material handling. As I scroll through these, let's see what we can find. This is on fall protection. That might be of interest to the group too. We can take a look. These are, as you can see, you guys, these are available to all of you for free. And of course, they're common domain. They're not copyrighted. So you can, use them, to whatever advantage. Also, of course, as you can see, the extraordinarily broad list of topics that can help you to train yourself in terms of the unique challenge that a new company is, like you've not been exposed to it before, but hey, there's all kinds of resources available for you. Sure.
I think it's really important for people to know that if you're worried about shots, there is a mist, there's a spray that's fine for people as long as you're healthy.
That's odd. Oh, wait a minute. Fall protection, not probably.
You request a copy of it.
Yeah, there's, as you see, a huge variety. Not sure where I found the one on material handling, but.
It's interesting that it's industry specific with the mining or.
Correct, and there really are for a wide variety of industries. So. A comment on this one, you guys, on black lung disease. 8 people die every day in this country from black lung disease, just to put that in perspective as well. So occupational illness, right, which we don't talk about very much, but it's still nonetheless a higher killer than injury rate. So, and of course it's the coal mining industry that, in fact, coincidentally, they were the very first OSHA, in a sense. It was called the Coal Miners Act of 1969. It's preceded the OSHA Act by 1 year, and it was in the state of Pennsylvania. And what it allowed was a coal miner to report a hazardous work environment anonymously. Because of course, as you can imagine, that's an extraordinarily risky and health challenge, especially for coal miners who smoke cigarettes, right? When you think about it in that light, and the likelihood is certainly very high that you're going to have a percent of those workers who have that exposure. But in 1969, and it was a state law, not a federal law, that was the first proactive occupational prevention in America. So did we luck out? For some reason, I'm not sure. Maybe yeah, maybe go back to the home page, Andrew, and see if we don't pick it up on another, and maybe go back one more to that list things up here. Yeah, this might be it.
This is Wikipedia.
Yeah, it would appear to be. I think so. This is what one I was wanting to use on this topic area for where we are in our discussion today. So, because this is where you're going to be probably encountering, oh, it's a printed rendering. There's a video though.
Yeah, I don't quite see what it'll make it there.
Wonder, oh, might be here. And of course, sometimes it's valuable for you guys to have the written rendering of it too. So that's also available to you. Now we're back to where we were a moment ago, right? Oh yeah, I think there is some. Here's one. No, that's oh, I think I did. I think I went to the menu. Yeah. Well, I think maybe we've made the point, though, for you guys to just realize that it's available. There's a great amount of information available to you. And again, you can just continue your own education. If you're a taxpayer, you can also get a lot of printed material for free, the publications. I probably got a half dozen manuals and books and guidelines and all of this stuff. That was before it was available on video. And of course, that was part of our original training from the 1980s and whatever. So thank you, Andrew. I think at least you guys, with a little perseverance, I know you'll be able to pick up on it. I don't want to take more time to expedite the information that we want to share, because we still have a great deal of information to cover. So what I'd like to do now, go ahead, Chad.
I'll just throw out there too, in addition to the NIOSH site, another great site for resources, meaning checklists or these types of things, is from a ergonomics company called Ergo Plus. And their website, they have a number of tools that they put out to industry that are just fabulous, really high quality stuff.
They're for-profit.
They are for-profit business, right? And
you have to subscribe, and then
yeah, on their site, to get their checklists and their white papers and all of those injury prevention guides and those types of things. What they ask you to do is put down your contact information. So they provide it free, and in exchange for you entering in your email address, and they don't harass you or follow you up with any other issues. It's just build their database, I'm assuming. So, but really, really good tools from that company. They have, again, a fabulous proactive approach to this process that I think is real valuable, and their stuff is very good.
Everybody get that name? Okay, cool. Thanks, Chad. What I'd like us to do now, you guys, is provide a case study in a sense of what we can share. Now, I would, to be fair to Viricon, these are some of my original photos, and obviously that's now coming on 30. I started in 1980 working with them. So for our students, sometimes they say, well, that was before you were born. But the bottom line is that this imagery is still useful as a teaching mode, even though I know they have substantially increased their technical capacity to deal with manual material handling. But we talked a little bit about earlier the notion of a lean bar, and then the notion of, shall we say, an at-risk situation like a barrier, right? Barrier prevents optimal posturing. Your body's ability to maintain its mass over its base of support without a load moment, right? That's the basic idea. So in this case, you'd say, well, observe the barrier that prevents optimum work posture, and say, well, gee, this looks pretty close, right, to the ASIS, and that maybe he could lean on that to prevent what I described earlier. But then look at where he's standing, right? It's an extraordinarily vulnerable, precarious position to be able to, efficiently do that job. And so I bring that out is that while that could serve as a lean bar, but in this case we'd say no, it really shouldn't be considered as such. It's a really awkward kind of situation. And this is the load that is to be transferred, and that is going to be this is going to go into an annealing oven, and it's going to curve. This is a windshield of like a garden tractor or a snow, like a machine for snow removal. And the weight of this object is 34 pounds, to give you, a little bit of an idea. This is the bench upon which it rests in terms of, its accessibility to the worker. And then I'm going to ask you to think about this for a moment. If you were to pick up that, and it seems to me it was 38 inches wide. So picture, like a yardstick, only a little bit wider. So if you're going to pick up that object, would you pick it up side by side, or would you pick it up vertically? Just think about that for a moment, and then kind of make a mental note, and then see the way in which he's picked it up. I'll back up for a moment, because you'll see how his arms are in relation to that load, right? Do you see that he's picked it up top to bottom compared to side? Now, by picking it up top to bottom, what is he forcing his body to do? It's got a good amount of twist factor there, right? Now, this is strategically being placed into this container, but this container, let's see if it does show it. Not real sharply clear, but if you were looking at a toaster and how a toaster gets red hot, the filaments. Well, that's what this thing is going to go through, this annealing oven, and it's going to get like 1200 degrees, and it's going to melt that glass over this frame. This frame is. So the interesting thing, though, and notice where the fingers, in order to position it, they don't just plop it in there. They have to strategically place it, right? So he's bent in this really precarious position, bending forward, and then, of course, as we said, he can't efficiently hold it side to side as he might intuitively want to do. Did most of you think you'd probably pick it up side to side? Or did you think it would be more efficient to pick it up top to bottom? So the idea is that the design of this container, in a sense, is where it has to be positioned carefully. There's no finger positioning hold here, but they position it so that the fingers, so that it can be positioned there, are on the bottoms. And I suggested, well, maybe in a redesign, it would be more desirable to have those finger holds to be placed so that it would avoid the twist component. I use that as a simple example for you guys to be reflective of. What do you see here? Anything come to mind?
The male, female, for one thing, I don't know if that's going to come in, the height difference.
Yeah, the height difference is the point that I want to make. In this case, they're both male. But when they were to lift on that object together, well, it could have been a female, and that might have been another component of it, because there's a difference, obviously, in the anthropometrics, right? And so the question is now, in their, transferring it, one would want to take that into consideration. The general rule is, if you're lifting typically, that is with your feet close together, which is what most workers do, unless they've had training in power lift, well, then this could easily be a situation where it could put both of them at risk, right? So you'd want to team people up in terms of matching their anthropometrics. As we said, though, not only their vertical height, but also their reach capacity. Because some people, who are I'm 5'10", and I have arms, though, probably equivalent to people who are 6 foot or taller. I just simply have longer than average arms. And that's, of course, what you're going to encounter on a regular basis. So it's just another thing to be reflective of. Do you see anything else, though, that could represent an issue? Pardon me? Yeah, it's got the potential for skidding there, but maybe it has brakes, maybe not. I don't know that, but it's a point. How stable is it, for example? You'll see another example of that in a moment. But there's one other point. Okay. Is there a real potential, folks? For, again, it looks so subtle, but could it involve somebody fracturing their wrist, right? Absolutely. And that's what we mean about zero tolerance. Even once a month, if you encounter that, that's too often, right? You have to really get middle management and the workers, right? They have to understand it's their wrist. It's their wrist, right? It's not the employer's. I mean, ultimately, it's a win-win. Talk about stability, right? Talk about a stable or less than a stable transfer mechanism. This is it's also referred to as a truck. Their slang is that it's called a submarine. They call it a submarine. But the bottom line to it is the design is such that these wheels are slightly, maybe a couple millimeters off the ground. See, it pivots on this large wheel, so it can pivot. It literally has great mobility, but the point is, obviously, it's also very unstable. I should mention that this would be an unusual set of circumstances from the standpoint that this would be a very small transfer mechanism for some of the pieces of glass, which you'll see in a little bit. So I'll defer for the time being. But one point that I suggested to them is that this wheel is made of metal or steel, and therefore it has no shock absorption whatsoever. And I suggested that they rubberize, hard rubber. And then also, of course, you see these seams in the cement? That's another issue, right? And when cement is brand new, it's pretty smooth. But over time, it's going to break up and it's going to have another issue for adding to the stability factor. Andrew, I think for a moment, if you don't mind, I'm going to cut the light, if that's going to be okay. The reason being, you guys, I'm going to ask you to look for something of pretty serious concern here. Your first impression, of course, is one thing, but take another careful look. What do you see on the left, on the right lower corner? Yeah, what do you think of that? And what do you think of that crowbar in relation to that? And what do you think do you think it might be relevant to have a hard hat? I mean, this would be a classic OSHA issue, folks, right? I mentioned that from the standpoint of OSHA almost never comes unannounced because they're simply understaffed. They don't have the funds, and they don't have the, where they do just checking on companies. Almost always they have to wait till there's a complaint, right? A worker who says, oh my God, I'm putting my life at risk here. And unless that happens, well, OSHA's likely not going to be making a visit unannounced, which of course they have the authority to do. I would tell you, now you can get an idea though of the size and the bulk of the glass that's being, now notice the table, notice the ergonomic engineering modification to allow what they're moving onto, it's a load being transferred, right? We're calling manual material handling. In this case, the object is a piece of glass that weighs 182 pounds, right? But notice how close it is to their carotid artery. You think glass has got some potential risks associated other than just the weight and the awkwardness of handling it. It's extraordinarily heavy. And of course, you can see the gloves. You can see the application. Well, we'll see that in a moment. But think of the tools and think of the stress factor of those hand tools, which we'll talk about in a moment. But notice again the protective equipment that they're using. Here you'll see obviously how they protect their forearms and shoulders from the potential for cuts. At Viricon, interestingly, as a glass factory or glass fabrication facility, they have part of their slang is what they call a Viricon tattoo. And that means if you've worked at Viricon for any length of time, if you haven't gotten your Viricon tattoo yet, what that meant was, of course, big slice of stitch marks, right? I mean, it was so common that that's what the workers simply, as kind of like part of their humor in terms of the exposure factor that they had to deal with. What about the apron though, you guys? Is that necessarily only to protect the worker? Certainly it serves to protect that, but what else? Do you think it might also be necessary for protecting the end product? Because what if the worker who has maybe a nice sophisticated Western, belt buckle, and of course, indirectly, accidentally of course, scratches this beautiful piece of glass, right? And of course, what if it's maybe along the, see, this glass might be going into, for a while they had the contract for manufacturing all the McDonald's windows with the golden arches, the big M that was embedded into the glass. That was a Viracon contract. I don't know if they still do it, but you can see that that window, or that, let's say that series of windows, there might be 12 separate processes in order to create the end product. So the very first exposure, to harming the glass might be at this level, but what if it's at the 11th step that finally some artifact, right, a scratch? Well, then of course, all that time and effort and energy is being wasted, plus they're going to have to throw away that piece of glass. That's called quality control, right? Quality control is in every manufacturing facility. But of course, you want to minimize the potential for that. And so, of course, the use of that apron, right? It does protect the worker, but clearly it's going to protect the glass as well. So kind of put that in perspective in terms of, your role to appreciate and understand what's really happening here. Yeah, of course they will be. I don't know if this guy's, yeah, I presume that. They look kind of like sneakers, but did you know that there are safety sneakers? Which has a nice advantage because they're usually much lighter, the weight of it. There's another slide in a minute that will talk about that. Yep, that's another point in terms of, like we said, a zero tolerance in any cutting activity. Let's see if there's a couple more with regard to this particular workstation. But yeah, this is probably the most serious, issue among all of them. Also, I guess the point I wanted to make, it looks like there's 1, 2, 3, 4, possibly, I'm not sure, I'm getting a little bit of a distortion. There could be as many as 6 layers of these crates of glass. Maybe each crate has got like 6 or 8 pieces of glass, and so it's maybe 800 pounds or who knows what. Each piece of glass is 182 pounds, so if there's 10 in there, that's already a ton, right? Just imagine the amount of bulk physical labor and why why they're transferred by machines instead of by people. Now that's good and well as long as he's got this nice platform, but what if he's down to 3 instead of, right? Instead of 3 feet to stand on, now he's on 15 inches or whatever. Do you get where I'm going with this? So this is only one moment in time, which brings up another point that was touched on a little bit earlier. I think you mentioned a little bit, Doc, in terms of, I was able to go into this facility and take photographs because I was assigned the task of helping them with ergonomic suggestions, right? But of course, I signed do you guys know the word proprietary? That's what it is, folks. It's like industrial espionage, right? Or industrial, you can, really understand. It actually began during a time when, in fact, it wasn't regulated. When cameras, people could literally go on a tour of a workplace facility and they would just take pictures. And of course, inadvertently, sometimes it would be, information that would have been considered private or protected, proprietary. And a lot of procedures, by the way, are never patented. They're not protected in the traditional sense of like a patent. But a process is equally important to what a company owns. They own the proprietary means or mechanism or process by which something is accomplished. And so now they really are careful. So we would, consider 2 things. You could do, in this case, these are static pictures, right? They're just photographs. But obviously, in order to capture the actual process, you'd probably do it by video, right? Then you capture motion, which has an advantage. And you can stop and start, and you could use it both then for static appreciation or for the motion component, which we'll get into in a moment here when I'll give you an example, though, of when and where there's an advantage to having just a static photograph. So again, what do you observe, folks? Do you see something? For example, does this remind you of anything? How about the controls on your adjusting tables, in a sense, right? What does this represent? An adjustable work surface, right? In other words, it has the capability. Within this tank, there's probably hydraulic fluid, right? So it's an electric motor which activates the hydraulic lift and so on. Now, in regard to what you're seeing here, you guys, notice the angle with which this woman is holding the tool. What they are actually doing, you guys, is putting a seal. This is called a triple glazed window. That means there's a layer of glass and a layer of air, another layer of glass and another layer of air. Keep in mind, this is when energy consciousness started to become a very grave concern for the corporate world. Remember, it was in the days when you had to wait in line to fill your car with gas. It was the same kind of thing when, every new school was built without windows, right? It was kind of like, holy mackerel, every school in the past had windows on at least two sides and whatever. Well, so energy conservation was a big part of the notion at that point. And so these kinds of insulated windows were in high demand. And I think now, of course, they are more efficient and whatever. They probably do it with two pieces of glass. But there is a layer of air which serves as a level of insulation. Okay, so to that end then, they're creating that type of glass. As you can see, it's a pretty thick industrial type window. And they're putting the sealant around it. He's putting it between the different layers of glass. She's simply scraping off the excess, right? So who do you think adjusted the vertical height of this workstation? Do you think the man did, or do you think the woman did? We think so too, intuitively, and probably not without much coaching. She probably found that that was the way her forearm was the most efficient. The young man, his tool is a feeder, and it mixes both an adhesive as well as the actual sealant material, but it has to be it was a mixture. It's a mixing gun. And so there's a certain amount of dexterity required, but notice that his arm is more extended, right? So, you have to look at the biomechanical advantage or disadvantage of that and the position of where it is in space in relation to his anthropometrics. Makes sense? I mean, that's what we're saying, but there's two workers, both, essentially doing the same thing, but yet there is this unique difference. So we suspect, again, that it's probably the woman that made the adjustment for the most desirable height. You can observe, again, these workstations, that they're adjustable in their vertical height capacity. And then you'll notice this concept, which is another really simple but powerful consideration in the workplace, and that is to avoid lifting. If there's a way in which you can slide it or glide it instead, then that would be more desirable. And of course, these are all like they would serve in a sense as a ball bearing. They're embedded so that it's rubber, so it doesn't offend the glass. Do you get the idea? Again, we're protecting the product as well as facilitating the ease of transfer. So here again, you see the load moment concept, right? So what's wrong with, she's actually working in quality control. That's what her job is. I remember this from having, observing these workers and to say, oh my goodness sakes, can't we raise that up? I mean, can't there be some kind of a means where she doesn't have to keep, doing this? Obviously, of different sizes, right? But anything that forces the worker into this posture on a repetitive basis really leaves her extraordinarily vulnerable in terms of the production of the load moment, as you can see. Now this is one wherein we'll probably allow you guys to have some quiet time. to reflect carefully on this particular slide and how many ergonomic issues, based on what you've learned so far today, you guys, what things do you observe? And let's give you a little quiet time, maybe make a mental list, and then we'll go around the room and see if we can spot them. Think at one point we think there were about 11 separate issues that I think probably deserve some attention. We'll probably wait. Just give yourself a little bit more time. See if you can find 11, right? I think there are 11. Maybe there's more or less. It's a little while since I've done this, but I know there's quite a large number. So just give it some thought and see if you can find as many as you can find.
What's the process?
That's a great question, isn't it?
She has a bucket of something, so I imagine she has to go into that bucket and do something up there, but is that
Okay.
cutting or heating or?
Okay, this might be an opportunity to talk about the two concepts that I'll share more with you about tomorrow. One is called a jig and one is called a fixture. This is a fixture. What does the fixture do? Well, it's defined as any kind of a device that allows the worker to have both hands free. So it anchors. See, one of the things that Viricon was doing, I don't know if they're still doing it, but they were providing window frames for what they call, the moon roof in a vehicle. Well, these were for these big recreational vehicles. So it's kind of like a mobile home on the road kind of thing. So you can see they're big windows that were designed for that kind of vehicle. So she's creating one of the inserts for that frame that would surround the window that would go into a vehicle, a recreation vehicle. So she reaches up and she takes one of, see right there's the solder. She's soldering or welding, if you will, but I think it's a type of a solder. And so each of these corners has been welded by this person. So she takes this has gone through a bending machine to the, to the dimension that it's required. But now there's one loose end, right? One loose end that needs to be soldered. The rest of it is solid. It went into a bending machine that did that. And now she's soldering or welding that corner. That's her job. In order to facilitate that, they're placing it into this angular steel receptor mechanism that's open at its bottom, but it holds it precisely in a precise 90-degree angle so that she can accommodate this by using both hands, right? So it's called a fixture. It's an example of it. If it were a jig, which we'll talk about tomorrow, it would mean that it would be mobile. And she could twist it, tilt it, invert it, that kind of thing. That's the difference between a jig and a fixture. And there's another point that we'll talk about in that regard, but that's what she's doing here. So now we'll ask ourselves, because by the way, they considered this one of the light duty jobs. They would put people on this that were struggling to return back to their original job. So this is one of what they called an accommodation job, a job that we would be provided for workers that were in a restricted work capacity from their regular job, because this was so easy. And the reason is that management said, well, it's only 8 pounds. That's the maximum lift. So it met the requirement of every doctor that put a restriction on the worker, say no lifting more than so-and-so pounds. Well, this would have fit easily, right? But every single worker that was working on this complained. And so management asked me to take a look at it and say, well, it looks like it would be an easy job. What's going on here? You guys ready to start giving some feedback? Who wants to be first? Go ahead. Does she ever? Okay. Does she? Yeah. When you think of, okay, here's a vertical line right through her base of support, right? Of course, she bears her body mass, right, on her base of support. And her lower extremities up to her pelvis, but right there, folks, right there, because it's what? Too far away, right? Does it exceed fingertip reach? It does. Thus, it results in the creation of a load moment. So do you think they would complain of lumbosacral distress? Yes. So that's one issue. Do you see another load moment, though? Here and here. See, this is considered then a vertical vector in relation to a horizontal vector. So cervical thoracic symptoms, absolutely. Shoulder, arm, hand symptoms, of course. Lumbosacral issues, of course. And then you notice something else. Look really carefully. And this is the point I wanted to make with regards, sometimes there might be an advantage to having a still photograph, because if you were doing it and visualizing the motion, you might not pick up on the subtlety of another load moment. But see how her garment, in this case, as you can see, it's denim, heavy-duty denim cloth. But notice what's happening. She's literally what? Wearing that cloth. So you can imagine what's happening to the quadriceps muscle. She's literally physically leaning on it as a lean bar, right? In a sense, she's trying to unconsciously use it as a lean bar to, facilitate reduction of the stress. Instead of a strictly forward flex, she's leaning against it, but of course it's stressing to that point. So that's a couple of issues. Continue then. Who was next?
Going back to whatever's in the bucket on top of the other bucket.
Ah.
It seems to be too low. It should be higher. She has to go back and forth between there.
Brings up this point then. It's a great point. Thanks. I think it's, I'm going to ask you guys then, what about the rusty bucket beneath the stainless steel bucket? Who do you think provided her with the rusty bucket? Do you think some knowledgeable, ergonomically trained specialist or professional said, hey, Mary, you ought to raise your bucket, right? Ah, what do you think, folks? Is that reasonable? Of course, because she said what? At the end of the day, I had more energy left, right? It was just miserable because I had to read so far and repeatedly, over and over. It only probably takes 30 seconds, 30, maybe a minute at max, right, to do this job that she's doing. So that's a great point. Okay, what else is related, pretty closely related to one of the things we talked about earlier, guys? What is the position of that stainless steel bucket in relation to where her body mass is? What is she going to be forced to do? To twist, right? Unless she is going to do what? Nose to toes, right? So you got to train her to do that. But when doing so, now let's take a look at what she's standing on. She's on a shop mat, but it's one of those kind that was really designed for what? A machine shop. See, that has openings in it to catch metallic filings. Pardon me, what is something happened? I'm sorry about that. Back up. So, there's another issue with the shock mat. Anybody want to comment?
Based on how narrowly it's placed, she probably doesn't move left or right very much, so she's immobile for probably a good part of her work.
One thing she has the advantage of, though, she will turn her body to reach up to grasp the next one, right? I mean, if this were a video camera, you'd see her total motion. But I use this slide to point out, if you were just capturing the video, you may miss some of the subtlety. That's why I'm suggesting you guys to realize that there may be an advantage to taking still photos to see then what other considerations. So let's stay with the shock mat for a minute, you guys.
Does she have to carry those frames back and forth? Does she trip over it?
What about the edge of that shock mat? And what about people, what if you were going past it with this guy? No, wait. What if this guy were coming in the neighborhood? Where did it go? You saw the one that I'm talking about, right? Anyway, you remember that little submarine? What if that came into contact with that edge, right? This guy, or this guy, where are we? Okay. Is that a catastrophe waiting to happen, right? So that 1 inch, she's standing up, but of course, trips and falls, right? And of course, she could trip and fall as well. So you're right, that's a great observation. Another one, though, relating to the shock mat, just for a moment, you guys, just think about it. And it's kind of like broaden your, think out of the box for a second. What about the color of the shock mat? Again, it's like the cement, right? Is it, again, going to be as noticeable as it could be or should be, perhaps? Could you use a beveled edge and have a softer material and have one that's smoother? Do you know about this thing called the coefficient of friction. Does that sort of ring a bell here? Look at her shoes in relation to the shock mat. Does that look like a pair of men's work boots? This is what we talked about earlier, guys. You can get safety sneakers, right? I mean, they're steel-toed tennis shoes, if you will, in the old language. So that might be a consideration for her, right? She clearly would probably, under OSHA regs need a safety-toed shoe, but the bottom line is that she's got and the likelihood is that shoe sole has also probably got the same design, right? Probably got the crisscross, heavy-duty, so lots of friction when you're going to tell her to move her toes when she moves her nose, right? So, or as she moves her nose, she's going to have to turn her body, but she's going to have to do so with a definite amount of drag or friction, or let's say fatigue, right? It's going to be a stressful activity that could be reduced by modifying the shoe and modifying the shock mat to accomplish a better end. What else? So why is she, what's the origin of the load moment? What's the issue here, you guys? It's too what? It's too far away, right? I mean, literally, this, where she needs to reach, is this a barrier that prevents optimal posturing? That's really the point, you guys. This is an example of a barrier. And then there's a couple of other considerations. If you look, that's why I wanted the lights to be removed. See these little red dots down there? That's the control of it's probably an electronic. It's an electrical mechanism that actually heats the solder, the flux, or the different components of the welding material, right? She has to activate that and hold it down for whatever. And when we get into our discussion tomorrow on controls, they need to be what? User-friendly, right? And the point is, it looks like they are really in an inconvenient place for reaching, right? So that's another issue. We're getting around 8 or 9 or 10 so far, right? Trash on the floor, absolutely.
The other stress on her wrist position?
Could easily be a lot of repetition there. And again, the question is, are her wrists allowed to remain neutral? Or is there ulnar or radial deviation could be a factor?
How does she move that once it's out, when she gets done with that process?
Picks it up with both hands and just hangs it on that thing.
Looks like she's having to stabilize it with her left hand.
Yeah, she has to hold it still. So I have a feeling that maybe as steady as it might, it could be that, or maybe she's leaning. You know what I mean? Maybe taking some of her body weight, just like her knee. Maybe she's facilitating because she's off balance, so to speak. I'm going to just, we're at that stage now, you guys, where we're winding down for the day. But I'm going to ask you to think about this for a moment. Look at the fixture. Ask yourself, is there anything odd or unusual about the fixture as we defined it earlier? Anything odd or unusual? And I'll coach you. In the interest of time, I'll ask you, what color is it? You mean, what color is it painted? Well, yeah, that's the point. There is no paint, which means that what? Where did it come from? Was it some wise engineering design firm that put together this fixture for this process? Or what? Here's the clue, you guys. See this? See the weld marks? That's your clue. Where did it come from? They made it in-house. And know what? It used to be a bending machine. It's a retrofit. You see, they just, it was an old thing that they, were no longer going to use, and they crafted this device to serve as a fixture to allow this to happen. But again, what would we call it, folks? It's totally inappropriately designed to accomplish this end, right? Has this been of interest to you guys in terms of the broad picture of kind of saying, well, these are just basic, core, simple examples. Whether or not they still do this, I doubt it, right? You know what I'm saying? But on the other hand, I'll bet you're still going to see this in a lot of workplaces. Similar examples of this, I strongly suspect that that would be the case.